Alright, so we are going to be starting up. Hello everybody, hello. What we're doing is I'm figuring out what this abacus is. This abacus is a counting tool. That's what this is. So, good morning, good evening, good day, good wherever you are. Alright, so what we're going to do, hello, we're going to be learning how to read the abacus. Hello everybody, hello. Thank you so much for joining. I'm trying to... Bueller, hello. So this is a counting tool. This counting tool helps us, helps us read our numbers. That's all we're doing. That's all we're doing. We're just trying to figure out what our numbers are. So, hello everybody, hello. Thank you so much for joining. So, here is 1, here is 2, here is 3, and there's 4. That's it. That's it. So when we're looking, let's see if I did this. Is that working? No, that's not working. Okay. The top is a value of 5, and then we have 6, 7, 8, 9. Let's see if I did this. No? Nope. Hello. Hello, Eden. Hello. So what we're trying to do is we're trying to figure out this. I'm trying to figure this out. Thank you. All right. We have a 3-digit number. Oh, I should pin that. Sorry, I'm trying to do other things and I can't seem to get what I need to get. All right. Hello, everybody. Hello. Thank you so much for joining. Thank you so much for joining. My name is Lynette. We're here to read the abacus. Hello. Thank you so much. So, what is it? We're going to figure out this number. So, there we go. I have a 3-digit number. Here's my 3-digit number. So I have my hundreds, I have my tens, and my ones. When I'm looking, the top bit is a value of 5, the bottom bit is a value of 1. There's 3 of them here. So there's 3, and then there's 3 here. But notice there's 3 plus 5. 3 plus 5 is equal to 8. And then again, 3 plus 5 is equal to 8. So this number itself is actually 883. That's what this number is. Hello, everybody. Thank you so much for joining. Does that make sense? So this is 883. This is 883. So we're going to take, that's what that looks like, and then we're going to take this number. All right. So we're going to have our next number. Let me see if this works. Oh, yeah, that works. Maybe it works on iOS. All right, good. Thank you, everybody, for joining. So we have our next number. We have our hundreds, we have our tens, and we have our ones. So we have 3, 1, 1, 1. There's 3 of them here. Hello, Apex. Yes, thank you, Eden. Yes, it is exactly right. So the top bit will always be a value of 5, and the bottom is always a value of 1. Notice this one here is nothing's touching. So that means that these are not counted. This one is touching, so this is counted as 5, but then there's 2 here. So we have 5 plus 2 is equal to 7. We have 3, excuse me, 1, 2, 3. 1, 2, 3, 1, 2. Because this has that value of 5, this is 7. This is 5, this is 3. Yes, Apex. Created by... Yes. Yes. The abacus was created back in Mesopotamia, and... they were used like pebbles. What they did is actually traded pebbles. So, thank you everybody for joining. Thank you everybody for joining. My name is Lynette. I am here to teach you abacus. Abacus is a counting tool. It's interesting. The abacus just really lets you visualize your numbers. That's what it does. It helps you visualize your numbers, and that's what we're doing right now. Once we understand how to read the numbers, we can add, subtract, multiply, and divide. That's what we can do. That's what you can do on the abacus. So the answer here is 357. That's what that is. And then we have our next number. We have our next number, which is our hundreds, tens, and our ones. So we have our hundreds, our tens, and our ones. What number? It's a simple way. It's a simple way to learn. Yes, exactly. It's so simple. It's so simple. It's simple and yet powerful, which is crazy. Thank you, Eden. It is 870. No, it's not 70. It's actually 60 because one beat on top and one beat on bottom is equal to 6. Thank you, Lens. Hello. Welcome back, Lens. So we have 8, 6, and then 2. Yes. So we have 862. It's crazy. It's so crazy once you can understand, like, and the methodology is actually quite elegant as well. So when we're looking at it, I'll show you the difference between mainstream math and abacus math. It's fascinating. So we have our hundreds, we have our tens, and we have our ones. What number do we think that is? We have our hundreds, our tens, and our ones. How much do we have? Huh. Hello, everybody. Great. Thank you. It is 780. Well done. Huh. Let's see. It's broken. So, yes, 780, and it takes us to this number over here. And then we have our next number. What number do we think that is? We have our hundreds, our tens, and our ones. Thank you, Eden. Yes, thank you. It is 610. That's what it is. Thank you. So when we're looking, we have the 5. The top beat is a value of 5. The bottom beat is a value of 1. The bottom beat is a value of 1. So this becomes 6, right? 5 plus 1 is 6, and then this is 5. I'm new to the channel, but I only teach abacus. The only thing, I only teach abacus. If you're looking for something more like algebra, if you're looking for like algebra or calculus, I can send you to somebody. But I only do is basic arithmetic. I have books, and I have the abacus, and that's what I sell. I'm looking for calculus. If you're looking for calculus, send me a DM, and I will send you to Robert. He does calculus, and I don't think he's on right now. But he does calculus. Send me a DM and I'll send you who he is. Is he on right now? No, he's not on right now. But sometimes he comes in my room, and he'll do calculus. So yeah, Caprice, send me a DM and I'll send you to him. Yep. I was just wondering. Oh, yeah, not a problem, Apex. Yeah. People ask me, it's like, nope, this is all I do. I've been doing abacus for 20 years. And it's been interesting because I've been able to uncover a lot of the things that mainstream math does, that abacus does better. Yeah. It's very interesting. Huh. It's broken. Oh, no, it's not. There we go. Okay. So we have 610, thank you, and then we have our next number. Let's try that again. So we have our hundreds, our tens, and our ones. What number? Thank you for the donut, Caprice. Thank you for the donut. I appreciate that. I learned about the abacus learning on my own with computers on YouTube and Google. Yes, but they don't teach the way they don't teach the way I teach. Because you learned about big friends, little friends, didn't you, Apex? And did you know multiplication and division? Can we do multiplication and division? Not right now. I mean, you need to know formulas. You know what I mean? Do we know if Eden, were you part of the formulas? I don't know if you changed your name. So, formulas are all bases of math. Formulas are the basis of all math. Yes, it is. But there's specific types. So in abacus world, we need to understand how to make a 10, and we need to understand how to make a 5. Once you understand that, then you can add and subtract everything. It doesn't matter. And how it's different to mainstream math. Because mainstream math, they give you different strategies and many, many more strategies. But in abacus, you only need to know the set, and then you're done. That's all you need to do. So the first thing we're going to do is we're going to continue to keep learning how to read the abacus, and then we're going to go into adding and subtracting. And then after that, we'll see if we can get into some multiplication. Division's a little bit more complex, and I don't really enjoy introducing it to a lot of beginners. I'm the one with the crazy alts. Crazy alts? I would have to remember what your thing is. I'd have to remember what your username is. Oh, crazy train! My God. Hello, Ebony! Oh, thank you so much. You were great last night. Thank you, Ebony. Crazy train. Oh my God, crazy train. All right. So, we're at 16 people. All right. We're at 16 people. How many people are brand new? I like your channel so far. Keep up the good work. Thank you, Apex. Thank you so much. I appreciate that. Trying to get multiplication going. And division. Me. Okay. So, I'm brand new. Okay. Well, but Apex, you know the Abacus, right? So then there's really not much for you to... You know the Abacus. So, what we would just do is we would just do adding and subtracting. We have our numbers. We have our ones. We have our ones, our tens, our hundreds. So when we're looking, we have our ones. This is 1, 1, 1, 1, right? This is 1. So there's 4 ones. This is a 5, and then we have 4 ones again. So this is 4 ones, and then we add the 5. This is actually 9. So when we're looking, this is 9, 5, 4. I know the Abacus. I just happened to pop up in Doom Scroll. No, I understand. Yeah, but so what I would be teaching would be like big friends, little friends, and I might touch on... Do you know how to do multiplication, Apex? Multiplication on the Abacus. And division. That's what I wonder. Do you know how to do multiplication and division on the Abacus? So, thank you everybody for liking the live. We have 459. That's what that is. So, 459, and we have our next number. We have... Notice that anytime the beads are touching the horizontal bar, it's considered counted. So, we have our ones over here. Your tens and our hundreds. We have 8. 5 plus 3 is 8. 5 plus 3 is 8. This is not 5. So here is 58. And then we have 9. 5 plus 4 is 9. We have 958. That's what that is. So when we're looking, we have our place value. We have our ones, our tens, hundreds, thousands, and 10,000s. No, I need a refresher. Like I learned a little bit when I was taking computer. Oh, I see. When taking the course, yeah. But when I teach it, the way I teach it is different than the way Abacus is, because Abacus is very has its own set of vocabulary that it doesn't make sense to a lot of people. So we're going to continue on. This is 958. That's what 958 is, and then we have our next number. So when we're looking, we have our hundreds, our tens, and our ones. What number do we think that is? So what we're doing is we're learning how to read the Abacus. After we learn how to read the Abacus, we'll go into some adding and subtracting. I'm positively changing the lives of the first... You too, Zubby? Me too. I know I've changed many lives teaching Abacus to everybody. Thank you, Ebony. It's 300.07. All right, so there's still some people... Thank you, Rain. Thank you so much. What we're doing is we're learning how to read the Abacus. And how are we doing? Should we continue on? We have 307, and it takes us to this. What is our next number? Our next number is our hundreds, our tens, and our ones. What number do we think this is? Oh, I have a new thing. I have a new activity. We can do a new activity. It's about what? Regrouping. It's regrouping. That's what it is. Thank you, Ebony. 452. That's what that is. 452 takes us down here, and now we're over here. All right. So we could do regrouping. Would be interesting. Yeah, I think it would be good to do regrouping. So we have our next number. We have our hundreds, our tens, and our ones. I missed the 5. Ha. Yep, I can see that. It happens. So when we're looking, when I do it, I usually look at the top. So if the top is touching, then I count down. So 5, and then 6, 7, 8, 9. 5, and then this is 1. So I know there's no 5. This would be 1. That's what I would do. Thank you, Ebony. 100, 195. That's what that is. 195 will take me up here. That's what 195 is. And then, what is that? That is 2 digits, right? Because there's only 2 digits touching the horizontal bar. So we have our hundreds, we have our hundreds, our tens, and our ones. What number do we think that is? I'm going to put this on, and I'm going to leave it on. All right, there we go. Yes, thank you. Thank you. Yes, Ebony, thank you. Thank you. It is 86. So we have the 80. The top is a value of 5. The plus 3 is 8. 5 plus 3 is 8. 5 plus 1 is 6. Thank you, everybody. Thank you so much. And then we have our last number. Our last number is... And then we're going to jump into some adding and subtracting. So we have our hundreds, our tens, and our ones. What number do we have? We have our hundreds, tens, and our ones. Thank you, Ebony. 306. Thank you. Sorry, 400. You're right, Rain. It is 406. Yeah, 1, 2, 3, 4, and then 5 plus 1 is 6. So we have 406. That's what that is. So for those of you that are interested, I do have this book available in my TikTok shop. You also have the opportunity to purchase the Abacus, or you can. I think it comes with either the 7-column abacus or the 13-column abacus. It is up to you. And what's the difference? The size. The colors mean nothing. So when we're looking at it, it works exactly the same. You just have more digits. You just have more because size matters. It's a bigger abacus, you get more numbers. That's all. You get a smaller abacus, you get smaller numbers. This one only goes up to 10,000s. So here we are. You'll notice that there's a label right here. This label, this label right here tells me this is the ones place. So we have our ones, our tens, hundreds, and our thousands. Notice the thousands. We have a dot here. This dot is like a comma. It's like for readability. So when we're looking, we have the hundreds and the thousands. So it's the same thing with this. Right? We have our ones, and notice there's a thousands. So it's every grouping is a place value. Every grouping is a comma. So we have our ones, our thousands, and then our millions. So let's go back to this one. Just like a comma, right? We have 3,456. So notice the 3,000 is it's easy to read because of the comma. So we have 3,456. That's what that is. And then if we want to take it one step further, we could do 73,000, right? 73,456. 0.25. That's what that is. And then if you notice, the dot, right, is here, not here. The dot is a label. There's the decimal, which you would have to kind of imagine. The reason why is because this would not be another decimal, because there's no 2 decimals in any given number. There's only 1 decimal and 1 comma. That's why this is considered a label as opposed to these. These would be this is just a label. So you can actually choose, right, I'm sorry. So you can actually choose, we can actually choose your number here. This will be your ones place. You could use this one to be your ones place. So then you would have you can do a really small number. You can do 0.0001 to be a really small number, because I use this one to be my ones place. Yeah. So if I did this and I go back to my ones over here, I have this number. If I have this number, let me help you.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
This is 55,555.55. You can do a whole row of 6. You can do a whole row of 8. You can even do a whole row of 9. It would look like this.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
So that's what it is. We have 99,999.99. That's what that is. And when we're looking, you'll notice that we have everything as a place value. Every column is a place value. Ones, tens, hundreds, thousands, and then 10,000s. Cool? All right. All right. So there's only 10 of us. I'm not sure if anybody else is still here. We can do something new. There's this one. What number do we think this is? number do we think this is? We're going to start doing some, we're going to do some subtraction right now. What number do we think this is? We have our ones, tens, and then our ones. Thank you, Ebony. It is 18. So guess what? So the chart is, we want to take away the 9, right? So 18 minus 9 is what? Well, I cannot take away the 9. So what do? To minus the 9, I have to minus the 10 plus the 1. Do you remember that, Ebony? I don't know if Crazy Train's still here. So we're going to take away the 10 and plus the 1. Do I need to explain it with the bricks? So my final answer is 9. I think I want to switch it. So what is my next number? I have this number. What number is that? 15. Thank you, Ebony. So it's 15 on the abacus. This is 18. I want to take away 9. So if I take away 9, hello, Rain. Thank you. So if I take away the 9, oh, Rain, you don't understand. Okay, sorry, Rain, I forgot. Okay, if I have 15 on the abacus, I'm going to do 15 on the abacus. I want to take away 9. Okay, so in mainstream math, this is 15, right? 5 plus 5 is, and then this is 15. So this is abacus, right? And what abacus means is we're going to have to break this number. We're going to have to break the 10. We got to break the 10. Why? Because we got to take away 9. What we want to do is we want to take away 9. Because we want to take away the 9, we break our 10. And this 1 that's left over needs to go back to the collective, needs to go back to the ones place. So I take away my 9, that's taken away. So now I'm left with this 1. This 1 is added to the ones place. So I minus the 1, I'm sorry, where am I? 15, right? I minus the 10, and then I plus the 1. So my final answer is 6. That's what that is. So abacus does it a little bit different, right? We don't say, okay, 15 and then take away 9. We don't take everything to make 15. What we do is we know the complement. We know the partner of 9. The partner of 9 is equal to 1. How do I know? Because what we're trying to do is we're trying to understand 9 plus 1 is equal to 10. Oh, okay, I'll do that again. 9 plus 1 is equal to 10. So let's do it again. So we have 15 on the abacus. Hold on, I'm sorry. There's 15 on the abacus, right? 15 on the abacus. We need to take away 9. Now, to take away 9, what are we going to do? There's 15 on the abacus, right? Notice there's a 1 here. That's the 10. So when you're looking at the 10, what do we have to do? We have to break the 10. So we break the 10, and look, when I break the 10, I'm taking away 9. But notice I have this 1 left over. This 1 has to add to the ones place. So I break the 10 and I add this to the 1. And I add it to the 1. So now my final answer is 6. 5 plus 1 is 6. So what we're doing is we're understanding the complements of the number. So I'm jumping in a little bit. Hello, marker, right? We're jumping into this. If I want to take away the 9, right, that's what I'm going to do. Does that make sense? So when we're looking, we're understanding the concepts. We're not going to take the whole thing. We're not going to be, we're not going to do 60. So here, the question would be, I'm not going to do, let's say if I did 65, right? If I did 65 minus 6, what does mainstream do? Mainstream says, okay, cross this out, make this 5, and then you have to make this 15. Does that make sense? But in abacus world, we don't need to make it 15 because we know, oh, not 9. I'm sorry, 9. It has to be 9 because we're at the 9. So we don't need to make this 15. In abacus world, thank you, Michael, for checking in. So in abacus world, what we do is we understand how to make this 9. 9 plus 10, 9 plus 1 is equal to 10. The 1 has to come from, the 1 is left from somewhere. The 1 is left from the 10. So we have 10 right here. And if I take away the 9, notice I have one straggling. Then I take this 1 and I add it to my ones place. So my final answer is 6. You're good. Thank you. Thank you, Fanta. You think so? How do you figure? So we do it again. We have what number is this? So we're jumping into, instead of doing adding, we're doing subtraction. I'm here for division. I'm not sure we're going to get to division. Let's see. Let's see. Dedication. Oh, thank you. Yes. I'm dedicated for Abacus. I'm here to introduce everybody to the Abacus. Yes. I do believe in it.
Welcome to the real world.
Division's actually not hard. Division's not hard. If you do it the Abacus way, division's not hard. It's just a different way. And I can show you, but division's not hard. We're going to continue on. What number is this? This is 17, right? So we have 17 on the Abacus. What are we going to do? We're going to take away the 9. 1, 2, 3, 4. We got to take away the 9, right? We got to take away the 9. When we take away the 9, we have 17. There's no more room to add the 7, right? There's no more room to take away the 9. Now, if you notice, oh, it's supposed to be 17, right? So the question is 17 minus 9. That's the question. Okay, see you later, Michael. Is Audrey still on? So here, we're not going to memorize that 9 plus 8 is equal to 17. We're not going to memorize that. Okay, I'll see you later. Well, I'm not doing division right now. You have time. You have time. So when we're looking, right, we don't need to memorize 8 plus 9 is equal to 17. What we're going to do is we're going to understand how to take away this 9. Taking away this 9 is, all we need to do is take away the 9 from this 10. See that? So I've taken away the 9 from the 10. I'm left with this 1. Because I'm left with the 1, she's talking about her books. I'll stop by later. Okay, see you later. So if you notice, I take away this 1. I'm going to add this 1. Why? Because I've already taken away 9. 5, 6, 7, 8, 9. There's this 1 left. This 1 has to go back to the 1's place. So you add the 1. My final answer is 8. Do you see that? So when you're looking, we take away the 10 because we got to break it. And then because we have a 1 left over, we got to add that to our 1's place. We add it to the 1's place. So our final answer is 8. We don't need to memorize 9 plus 8. What we need to do is we need to understand how to take away the 9. Does that make sense, Ebony? So we could do it again. So our final answer is 8. So we could do it again, right? We do 11. I'm good at patterns, so you always add 1. Yes! Yes! You always, for the 9, when you subtract the 9, you're always going to add the 1, no matter what. Yes. Actually, I take that back. Sometimes you have to, it depends on what it is. Not no matter what. It depends on it depends on the situation. So what number is this? What number is that? 22? No, 11. Thank you, Carrie. It's 11. So what's the question? The question is 11 minus 9, right? So 11 minus 9, again, what are we going to do? We have 11 on the Abacus. 1, 5, 6, 7, 8, 9. And then we have 11. This is my 1s, right? That's 11. 1, 10. So, right, this is 10. 5, 6, 7, 8, 9, 10. Right? And what do we do? You can't see that. What do we do? We're going to take away 9 from here. Take away 9 from the 10. So we got to break the 10. Do you see that? We got to break the 10. And guess what? That gives me 9. But then I'm left with this. And I got to add it to my 1's place. So now I have 2. Add the 2. So my final answer is 2. So what did I do? I had to go left to go right. I had to subtract. I had to add in order to subtract.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Okay? So when we're looking with the minus the 9, so my final answer is 2. So again, what are we doing? We're not memorizing how to make these numbers. We're memorizing what the formula is. So when we minus the 9 is what? Minus the 9 is equal to minus the 10 plus the 1. We do it again. Minus the 9 is equal to minus the 10 plus the 1. And we do it again. Minus the 9 is equal to minus the 10 plus the 1. Why? This is the answers. And now what we do is we don't need to memorize 9 plus 2 is equal to 11. We don't need to do it that way. We go the other way around. Hello, Shadow. Hello, Shadow. So what number is this? What number do we have here? Carrie, did that make sense? How to subtract the 9? So what's our next number? I had a test today. How did it go, Shadow? 16. Carrie, does this make sense? Thank you, Ebony. So when we're looking, we want to do the number, right? What is it? It's 16 minus 9. 16 minus 9. Again, we're looking at this number right here. What kind of test was it, Shadow? Minus the 9. What do we do? Minus the 9 equals to minus the 10 plus the 1. So what do we do? Minus the 10, we got to break up the 10, and then we got to add the 1. Why? Because we know that if we take away the 9, we're going to add the 1, right? Because that's how you make a 10. So we add the 1. So my final answer is 7. This is 16. It was an abacus test. Are you at a school? So we have minus the 9 is equal to minus the 10 plus the 1. What school, how long have you been doing abacus, Shadow? What number is this? What number is this? 4 months? Where is the school? Thank you, Ebony. It is 12. Wait, it's 4. You've been in the abacus school for 4 months? So are you learning big friends now, or are you still on the little friends? So what are we doing? We're going to do 12 minus 9. It's the same thing. Do you see the pattern? So we have 12 minus 9. What's minus 9? 12 and then take away 9. Minus the 10 plus the 1, right? So all we got to do is minus the 9 is equal to minus the 10 plus the 1. My answer is 3. I think, no, my teacher has been teaching me abacus and we had a test. That's my question. What are you learning in abacus? And we do it again. What number is this? 7 minus 12. Okay, so what do we do? There we go. Where's 12? 12 is 12 not here? 12 is not here. All right. 12 minus 7. What do we do? We have 12 on the abacus. Oop, 12 on the abacus. Let me get my bricks, right? We have 12 on the abacus. We want to take away 7. 1, 2, 3, 4, 5, and then 6, 7. All right, so we have 12, right? 5, 6, 7, 8, 9, 10, and then 11, 12, right? We take away 7 here. 5, 6, 7. We got to break this 10. 5, 6, 7. Do you see that? But guess what? Yes, exactly. Minus the 10 plus the 3. Do you see how we plus the 3? But you can't plus the 3 on the abacus. What do? You got to add it to here. Plus the 3 is plus the 5 minus the 1. I've made a 5. Does that make sense? So we have minus 7 is equal to minus the 10 plus the 3. Now if you look, I wanted to take away the 10, which we got. Now we want to add the 3, but there's no room to add the 3. What do? You have to make a 5. So this becomes 5. Minus the 5, or add the 5 minus the 2. So your answer is 5. This is what I call a two-step, because plus 3, there's no more room to plus the 3. So you need to plus the 5 minus the 2. That's what needs to happen. Does that make sense? Yeah, this is all available in my other book. What book is it? It is this book. Yep. Now we're doing minus 10s. Excuse me. Yeah. Thank you everybody for joining. If you were interested, you can go ahead and check in and let TikTok know that you are a that you're a human being. Does that make sense, Carrie? Good. I'm happy that made sense. Yeah. This is what I call a two-step. The reason why I call it a two-step is because you have to do 2 steps. This is 1 step. This is the 2nd step. Right? And so, phone froze. Oh, not a problem. So, Shadow, what did your test have? Yeah. Make sense? Cool. So we can do it again, right? And then we just keep going. So 7, what number is this? This number is, what number is that? 18. Okay, it's 18. Can we take away the 7? Do we need to use a formula? No, we don't need to use a formula. You just take away the 7. That's it. So my answer is 11. So we can do it again. So we have, what number is this? What number is that? $15. Thank you, Ebony. It is 15. Thank you, Carrie. So we have 15 on the abacus. I want to take away 7. Take away 7 is what? Minus the 7 is equal to minus the 10 plus the 3. Minus the 10 plus the 3. So my final answer is 8. Right? So that's the interesting thing, right? The interesting thing is, in abacus world, we always focus on the second number. Doesn't matter. Doesn't matter. Even when you're adding, we can focus on the second number. And that's what we call regrouping. What, right? That's regrouping. This is borrowing. So what we're doing is we're understanding how to borrow. But we don't really borrow. We actually take from the 10. You know what I mean? Because we have, what number is this? Oh, this is not a number. So this is 17, right? We have enough. Take away 7. Take away 7. So my answer is 10. Okay. Very clever. 11. I have 11 on the abacus, right? I want to take away 7. To take away the 7, what do? Minus the 7 is equal to minus the 10 plus the 3. What do? I take away the 7 from the 10. That's what we're doing. So we take the 7 from here, and then we're left with 3. So we got to add the 3. So my final answer is 14. No, 4. Which is interesting, if you notice, because in mainstream, you actually don't do it this way. I need more bricks. So let's say we had we had 41. 41 take away 7. Right? What do? In mainstream, you got to take this, you got to borrow from here and you make this 11. Right? But guess what? In Abacus, we don't do that. What does that happen? So you get 40, right? We get 41, and then we get the 1. We want to take away 7. What do? Well, we got to take this out, that becomes 11, and then you take away 7. 1, 2, 3, 4, 5, 6, 7. Oops, 5, 6, 7. And then you're left with 4. So you're left with 34. But Abacus doesn't do it that way because it's an extra step. So mainstream does an extra step, where Abacus, you don't need that extra step. Why? Because if we had the 10, right? If we had 10 over here and we want to take away 7, we take it away. See, we take it away. 5, 6, and 7. We take it away. And then what do we know? We know we're going to add the 3 to the 1's place. Yes, thank you, Rio. I did say 6, 7. Does that make sense? So then we take away the 7 like that, which is really kind of cool. And so my final answer is 34. So I don't do an extra step. Do you see that? So let's do it again. If I have 41 on the Abacus, right? And what I do is I take from here, I break my 10 and I take away the 7. When I take away the 7, I'm left with 3. But the 3 has to add to the 1's place. How do you do 1 plus on paper, like everything and carry everything? Here it is. So we have 1, 6, 7, 1, 5, 7. We're adding. Easy. So 1, 6, 7, right? 1. We add the 1 here. That's what 1 is. Right? And then what are we going to do? We want to add the 5. What is adding the 5? Adding the 5 is plus the 5 is equal to plus the 10 minus 5. Plus the 10 minus the 5. And then I want to add the 7. Plus 7 is what? Plus the 10 minus the 3. So add the 10, take away the 3. Cannot take away the 3. What do? Minus the 3 is equal to minus the 5 plus the 2. Plus the 5, minus the 5 plus the 2. So what's my final answer? That's it. I don't know. Was that too fast? Should I go slower? Was that too fast? Do I need to use bricks? Do I need to use the cubes? What's my number? Thank you. 3, 2, 4. Yes. You want slower? Okay. Let me go slower. Too fast? Okay. Sorry. 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 Okay. Let me do that again. We have 1, 6, 7, right? 1, 5, 7. This is an adding, right? So now what do? We do 1, 6, and then there's the 7. We're going to add the 1. Okay, here. Do you want to go left to right or right to left? Do you want to do the 7 first or do you want to do the 1 first? You let me know. Right to left. Okay. So 7 is what? How do you add the 7? There's no room to add the 7. Okay, we'll do the other way. We'll do the other way next time. So we want to add the 7. What is the formula to add the 7? We know to add the 7 is plus the 7 is what? To add the 7, what do? If I have 7 on the Abacus, I want to add another 7. What do? We know that adding the 7 to make a 10. So we need to make a 10. How do you make a 10? You use 2 of them. To make a 10, you need to get a 3. Thank you, Ebony. So the formula is plus the 10 minus 3. Thank you, Secret. Thank you, Yuji. So I'm going to plus the 10. That's what I did, plus the 10. But I got to take away the 3. There's no more room to take away the 3. Do you remember how to take away the 3? Do you remember how to take away the 3? Remember, to take away the 3, I need to what? I need to add the 2. To get the 3, I need to add the 2. So minus the 5 plus the 2. Then we're at the 5. How do you add the 5? Minus the 3 is what? Minus the 3 is equal to minus the 5 plus the 2. Now we're here. Now we're going to add the 5. Plus the 5 is what? No. How do you add the 5? Okay. We're going to have to go back a few steps because nobody remembers the formula. So plus the 5 is equal to plus the 10 minus the 5. So you plus the 10 minus the 5. Thank you, Ebony. And then we want to add the 1. So we add the 1. So our final answer is 3, 2, 4. If we did it the other way, 1, 6, 7, 1, 5, 7, we add the 2. It's the same. We add the 2, 6, and then 7. Right? What do we do now? Well, we got to add the 5. Add the 5 is what? There's no room to add the 5. So we have plus the 5 is equal to plus the 10 minus the 5. So we plus the 10 and we minus the 5. Now what do we do here? The 7. So plus 7 is equal to what? Plus the 10 minus the 3. So we plus the 10 and we take away the 3. Minus the 3, can you do it? No, you can't do it. So how else can you do it? So you minus the 3 is equal to minus the 5 plus the 2. I need to practice so bad. Yeah. So the biggest thing is understanding your formulas. You really need to know the formulas. Everybody always wants to talk about multiplication, but the biggest thing is once you understand these formulas, the multiplication's actually really easy, right? So when we're looking, these are the formulas that you need to know. You need to understand the complementary numbers of these. You know, yeah, everybody keeps saying that I need to have something more advanced, but then I always get these beginners, so I can't do anything more advanced. So it's the same thing over and over again. I don't know why I keep trying. So let's go back. Okay, let's go back. Hello, LD. Hello, LD. I took your advice and I started making more abacus. No, I don't give up on you, Ebony. I'm just saying that I can't go too far ahead because I lose people. So I can't go far ahead. So this one is going to be part of the new book. There's going to be another book. What we're doing here is we're going to figure out what this number is, right? Figure out what this number is. What is this number? I'm not giving up on you. I'm just saying that I can't do anything advanced. What number is that? 16. Thank you. 16. So what we're doing, LD, we're going to take away the 7. So we have 16 on the abacus. I want to take away the 7. Do you know how to take away the 7? Minus the 7 equals, yes, read the number and then solve it. Yes, that's what I did. Read the number and then we're going to solve it. What is minus 7? Because the top beat up here is minus the 7. I was trying to figure out new ways to like do it. Thank you, Ebony. It is minus the 10 plus the 3. So we minus the 10 plus the 3. 1, 2, 3. So my final answer is 9. Thank you, LD. Oh, I wasn't wearing my shirt. I was wearing my shirt yesterday. It was the... Did you ever go to Blunt Brothers? It was a coffee house back in the day. Blunt Brothers over in Vancouver. Did you ever go to that one? It's a coffee shop. Yes, I like it. Yeah. Oh, thank you. Yeah, I went to a coffee shop. It was a coffee shop in Vancouver. Coffee house. Yeah. This was one of them. And then I have it for the whole set. So I might, I think I'm going to do is I'm going to make a new, there's going to be a new book, but I haven't figured it out yet. Yeah. I haven't taken the time to rearrange the numbers, but that's the plan. So there's going to be, there's an 8, there's a 7, there's an 8. Thank you, Wheels, for the tiny diny. There was an 8 and a 7. Yeah, it was interesting. It was interesting. Oh, yeah. Okay. So you know what I came to this discovery today. Hello, Andy. Hello. Which book should I get first? Get the adult one. You know a lot of it already, Ebony. I would get the adult one. Unless you want to do the mazes, but I would get the adult one. Yeah. I'm not giving up on you. I'm just saying it just needs practice. And yeah. I like, yeah, you like the light, yeah? Yeah. I would totally do the adult one. And that would give you the practice. I believe it'd give you the practice. Obviously, I'm going to have more. No, I understand. Yeah, I was, because, learning is better. Oh, that's right. I wanted to say, okay, you know what I discovered? Okay. Like in mainstream math, there's like this, let's say this number, right? We do 4 plus 7, right? So what do? I plan to get the mazes once I finish the adult book. Oh, okay, cool. I was going to make the more mazes. I was going to do 5-digit, 6-digit, and 7 digits as the mazes. 41. Thank you, Dylan. But that's not the question. So here, in mainstream, what they do is they say, oh, you know what? We're going to make this a friendly number. So they take this and they make it into 40. But you know what? Funny, they focus on the top number. But then, if you were to do subtraction, you focus on the bottom number. Why? Why is there a flip flop? Do you see what I'm trying to say? Do you see what I'm laying down? Because they're focusing on the top. Whereas in Abacus world, we always focus on the second number. Always focus on the second number. Did you decide what times you go live? No. I was trying to go live today at 6, but I missed the boat. And then now I'm here. And then I was going to be like, well, when am I going to go live again? So I think this is my last for tonight, so I can go get some sleep. Yeah. I don't want to miss you. Oh, thank you, Ebony. Yeah, it's going to be right around this time. So I think I was going to do 2 at night. So 6 and then 9. That's what I was thinking. Yeah, thank you, Ebony. I appreciate that. But it was just interesting. Like, and then trying to get the books out. So, but yeah, like in the beginning, right? Like I was trying to, and it's not you. It was just the other people around that just made comments that just, I knew I was losing too many people. But it was interesting. It was just an experiment. Like this one here. You know what? We could do this one. Here is another book that I'm going to create. What we're going to do is this is for beginners. No, this is a beginner this is a beginner, but you still need to know your multiplication. This might be a good one for you too later. After you do the Abacus for Adults, this is addition, descending. So what we're doing is we're adding. I hate making mistakes. Don't worry about making mistakes, because we all make mistakes. Even we all make mistakes. Embrace the mistakes, Ebony. Embrace the mistakes, because we're always going to make a mistake. My whole life, right? We're always going to make mistakes. So you just embrace it. So here, I love learning. Oh, good. So here we have the 10. You showed and owned a mistake and won the book yesterday. Yes, I did. Fail forward fast. I did. And I got that corrected. I actually just republished. Yeah. Oh yeah, my books are full, not full of mistakes. My book has some mistakes, and because I'm making the mistakes, it's, it is what it is. Can you show me how to do a question? Oh. Okay, Jake. Do you know how to read the Abacus? I don't know what level you're in. I'm a beginner. Okay. So let's start from the beginning. Because I was going to show this. All right, but we'll go to the beginning. Yeah. Okay. Okay. Here we go. I love the process learning as I go. Oh yeah. Oh, did I show you this, LD? Wait, before I start, Jake, I wanted to show this. Did I show you this, LD? There's going to be a new book. So what we're going to do is we're going to add. Maybe have different levels at different times. That's not going to work. That's not going to work. I always get a lot of beginners. And if you're looking for something more advanced, then I would say subscribe to my membership. Because then we can really deep dive into it. Oh, so what we're going to do here, so this is the new book. The new book is another book. We're going to add the 1, and then we add the 2. We're going to add the 2, and then we add the 3. Notice there's no more room to add the 3. We're going to plus the 5 minus the 2. Plus the 5 minus the 2. So my running total is actually 6. So then we have to add the 4. Add the 4 is plus the 5 minus the 10. Right? So then we have 10. My final answer is 10. And then we keep going. We add the 5. We add the 6. Adding the 6. Can't do it. What do we do? So this is a warm-up exercise that we teach the kids. So we have plus the 6 is what? Plus the 10 minus the 4. Cannot minus the 4. We have to minus the 5 plus the 1. So my answer is 21. And then we want to add the 7. You add the 7. And then you add the 8. Add the 8 is what? Can't do it. Plus the 10 minus the 2. And you're supposed to write the formulas. So my answer is 36. And then we have to plus the 9. To add the 9 is plus the 10 minus the 1. So my answer is 45. And you go all the way to 100 till you add 100 all the way to here. Your final answer should be 50-50. That's one book. All right. So, let's see. Jake, are you still here? Okay. So when we're looking at the Abacus, what we're going to do is we're going to understand how to move the beads. Here is a preschool book. This was meant for a preschool book and for kids that are like 3, 4, and 5. But this is not for us. I'm just using this to explain that I wanted to get the kids young. And so I have some activities for the kids to be able to understand their numbers. And we go forward. They know how to count forward. They know how to count backwards. These are all the activities. After counting backwards, they need to figure out what comes in between. After what comes in between, they figure out what's surrounding. And then now we're going to go into adding and subtracting. We're going to do comparison, and then we go to adding, subtracting. Okay, that's a great way to learn how Sorbonne not to write the formula. That's a great way to learn how to read the Sorbonne and not write the formulae. Yeah, it was really interesting. Oh, there was another one. Oh, so I was making this comment where, remember I always say that we have to look at the second number. In Abacus world, we always look at the second number. But guess what? In mainstream math, you go up and down. Why? I don't know why. I don't know why they go up and down. So when we look at it, they want to make this into a 40. Because what happens is they focus this. They make this into the upper number. But in Abacus world, we don't. We always look at the second number. But the interesting thing is when we do subtraction, you always look at the second number. You always subtract from the higher number. Do you see that? Funny, right? The focus is here. So I don't understand why in mainstream math you focus on the top when in in subtraction you focus on the bottom. Interesting. All right. So we're going to continue on. Thank you everybody for joining. My name is Lynette. Here is an abacus. So this abacus tells you how to read the numbers. We're going to do a little review. We do 1, 2, 3, 4, 5. The top is the value 5. We have 6, 7, 8, 9, 10. So 10 is a 1 and a 0. We have 11, 12, 13, 14, 15. And then we have 16, 17, 18, 19, 20. 20 is a 2 and a 0. So then when we're looking, we actually have place values. So our place values are this. We have our ones, our tens, hundreds, thousands, and 10,000s. Notice that we have our decimal sits right here. There's a decimal that sits right here. So this is our tenths and our hundreds. There's a label. There's the 1. There's the dot right here. This dot tells me it's the ones place. So this ones tells me that over here would be thousands because there's another dot over here. Notice there's 2 dots. This is like a comma, like a readability. So just as we have the comma for the thousands, the dot would be my ones place. You could choose your dot over here to be your ones place, and then you would move everything over and it would look like that. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. That makes sense? So what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, you can add, subtract, multiply, and divide. Cool? All right. So we're going to continue on. Now, what we do is we need to add the 1. Well, we have 7 on the abacus, right? Remember 7. 5 plus 2 is 7. We want to add the 1. Adding of the 1 just means that there's enough. You add the 1. My final answer is 8. What book are we working on? We're working on the preschool book right now. This one right here. There we go. So if you're interested, I do have a... Hello, Jake, you're back. Abacus? I thought you left. Abacus. Or am I a math teacher? Yes, I'm teaching math. So, Jake, I thought you left. Oh, hello, Apex. Haha. Welcome back. So we have 8 on the abacus. When we're looking, thank you, April, for the follow. No, I did not. Oh, I'll be right back. Oh, okay. When you come back, we'll talk about more adding. So here we have 2 on the abacus. Notice that what we're doing is we're understanding how to plus the 2. We're not focusing on the first number and we're not focusing on the result. What we're doing is we're focusing on the second number. The second number is what tells us whether or not we're going to be adding or using a formula or not. So if we have 6 on the abacus, I want to add the 2. 1, 2. Is there enough? Yeah, there's 2. So all I got to do is just add the 2. My final answer is 8. And it's very interesting because in Abacus world, we just look at our beads and we can see whether or not we can use it. So here we have the question, right? 5 plus 3. Just like in mainstream world, right? You could do the dots, or you could do the tally marks. Is the blue column the ones place? No. The blue is the top bead. This is 5. I don't know what abacus you've been learning if you don't know the top beat is 5. Right? The top beat will always be 5. Just like this.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
The top beat will always be 5. 55,555.55. So here we have this number. We have 5. We plus the 3. My final answer is 8. You can subitize. Subitizing means what? Subitizing means that you can look at the number, you know what it is. So this becomes 8. We can take it one step further. We can actually do 50 times 30. 50 plus 30 is equal to 80. 8 and a 0. What is that? That's 80. You can subitize it. Hello, Robert. Hey, Robert. Somebody is looking for you. I've seen the abacus. Each column is a place value. You slide each bead, add and subtract the other. I've seen the abacus. Each column is a place value. You slide the beads to add and subtract another. Oh, Apex. That's a different type of abacus. Yeah, they were looking for calculus. That's all. I don't know if they're gonna DM me, and I'll send you over to them. Yeah. That's what I'm doing right now. So the top is a value of 5, and I want to add 3. 1, 2, 3. So my final answer is 8. 5 plus 3 is 8. So we can do it again. We can actually do 50. So 50 is 5 and a 0 plus 30. 30 is a 3 and a 0. 50 plus 30 is equal to 80. How's it going? It's going okay. I was trying to do something different. And I lost a lot of people. And then the room came down to be like 5 people. So then I tried to go a little bit advanced, and then TikTok said, I'm going to bring in more people. So then all these newcomers came in, and then I'm already in an advanced thing, and then I lost a lot of people, and I was like, whew, sorry. But yeah, it was just one of those things, like I'm trying to figure out like a nice medium. I think I got to just keep starting from the very beginning. So the blue bead's always worth 5? Yes, the blue bead's always worth 5. 5, 5, 5, 5, 5. These are all 5. So then we have 5 plus 2 is 7. 5 plus 1 is 6. 5 plus 1 is 6. So we can do it again. We add the 4 is what? The 4 bottom beads. That's what 4 is. All you got to do is add the 4. 4, whenever the beads are touching the horizontal bar, that's what's considered counted. This is 4. None of these beads are touching, so that means that none of these beads are counted. The 5 is not counted either. So then if you know how to add, you will know how to subtract. So if we have 7 on the abacus, remember, we have the top bead is a value of 5, the bottom bead is a value of 1. So then I'm doing last prep. So how often do you go live, Robert? And how's your room? I've seen videos of children doing hand motions. Yes. And that's what we're doing. I'm showing you the secrets of abacus. Are they doing an imaginary one? Yes. They practice with an imaginary one. So we have 7 and we want to take away 1. So that's what it is. My final answer is 6. Hello, can of cricket. Thank you for the secrets. No more gatekeeping. No more gatekeeping. So we have -2, right? So I have 3 on the abacus. We will take away the 2. And my final answer is 1. So notice that what we're doing is we're moving the beads. As you move the beads, you're going to understand how the beads move. So we have 4 on the abacus. I want to take away 3. Take away 3. 1, 2, 3. Take away 2. And my final answer is 1. So what we do again is we focus on the second number. You can't see that. You focus on the second number. The second number is what we focus on. You don't do the first and you don't do... Hey, Robert, when you have a question, do you go from left to right as you read? Do you ever go from right to left when you do a problem? I don't even know if that makes sense. Thank you, LD, for the abacus. Thank you, LD, for the roses, and Andy for checking in. I see that. I didn't mention it. It depends. But you're not Robert. I don't know if Robert's still here. All right, we're going to keep going. So we have 9 on the abacus. Notice that if we have the 9, we add the 9. We want to take away. I'm curious if she knows how to use this. I am. Can you clarify? Yes. So the question is. Okay. So the question is if you have a I don't know I don't know a question, but okay. So in regular questions, right? We go from when we add and subtract. In mainstream, you do the ones first, do the tens, and do the hundreds. So you go right to left. So my question is, in your calculus questions, do you ever read your equations from right to left? I have a theory. Because I think in algebra, you go left to right. Right? Because even when we do the order of operations, right? You go from left to right. So if there's an exponent or power, what goes first? Whatever's left to go to right. If you have a multiplication or a division, you go left to right. So if I did 4 divided by 5 times that by 3, when you do this, you go left to right. See? That's my theory. You usually go from left to right. I don't know why in elementary school they teach us to do right to left. Although sometimes I go down. Going down is different than reading. Because in mainstream, they always start from right to left. Going down is different. I knew it. Going down is different than going left to right. I don't know why they changed that in elementary school. Because when they do elementary school, what? One's place is first of everything and follows. No. In Abacus, we go left to right. We start with the 3, then we do the 6, and then we do the 7. Abacus does left to right. It's natural to go left to right. Even when we do this, right? If we do 4 plus 5 minus 3 plus 4, right? You can't see that. But anyways, if we see something like this, you go left to right. You don't go right to left. Order of operation, you go left to right. Interesting, isn't it? Left to right when dealing with tens? What, in mainstream? Mainstream, yeah, when you need to borrow, but no, you still go from right to left. I need paper. Because even if it was like this, right? Even if it was like 9, 8, 3, 4, minus 4, 7, 6, right? When you're doing this and you're doing a minus, you don't do 4 first. You do 6 first, and then you borrow. So I see what you're saying, LD, but you still start from here. Yeah. So you're still going from right to left, which is very interesting. Yeah, I'm trying to figure that out, because in mainstream they go right to left, but in Abacus we go left to right. Algebra you go left to right. Calculus you go left to right. We read from left to right. Very interesting. Very interesting. And there was another thing is, the other thing is like if we had the number, let's say 90, let's do 99 plus 4, right? So in mainstream, when writing only maybe, I never learned algebra. Oh, see, in mainstream, they take this number and they try to make it 100. But in Abacus, you don't take it from here. You take it from the bottom number. But you know what? If we did subtraction, you focus here. That's only the things we read. We read from right to left. We don't read from right to left. Yeah, that's in math is the only thing that we go right to left. Everything else we go left to right. And that's the other thing I was also discovering. In mainstream math, they go up and down. It doesn't matter what number they go up and down. But in Abacus, you always go top down. Always go top down. Doesn't matter. You always go top down in Abacus world. I'm talking about the math problems. Yeah, I don't know. I'm just thinking about these things like it's kind of crazy. Because in mainstream, they always try to make the top number like whatever, a friendly number. But in Abacus world, we don't. We always go top down. We always take from the bottom and then we go up. That's why because my friend and some other people, like my other friends were talking about it, and it's just easier on the Abacus. All right. So we're going to continue on. Yeah, it's just funny. Do a practice one the way you think it should be done. I think it should be left to right. But it is up to you to figure it out, to see if you like it from left to right. I think as we get older and we get into more complex math, we go from left to right. All right. So that was a little bit of a digression. Thank you everybody. So we're going to add the 4, we take away the 4. When we take away the 4, you're going to notice you take it away from the horizontal bar. So we have the 5, right? We have the 5. We want to add the 5. Add the 5, you go to the horizontal bar. I'm going to go live in a couple minutes. I'll stop by again if you're live afterwards. Oh, yeah, not a problem. Not a problem, Robert. Thank you so much for entertaining my thought. I just, let me know if you want to do a collab and we can start philosophizing about math. Right, LD? I like to philosophize about math. Because it's different in elementary school and all the other places. Everywhere else is different than elementary. Elementary school is like its own little crazy, complicated thing when it shouldn't be. You know what I mean? Hello, Rob! Hello, Rob. Thank you so much. How you doing? Oh my goodness. What is a Zanmag Loopy? I don't know what a Zanmag Loopy is. That's crazy. Yeah, it's in the process. It's very interesting. Like breaking down what they do in mainstream math compared to Abacus math. I feel like mainstream math is completely backwards. And there's no system to it. And they're just kind of muddling around. You know what I mean? Thank you, Rob V, for that. You're awesome. Rules and laws. Yeah, it's so interesting. It's so interesting. There should be a pattern, but mainstream math in elementary school, there's no pattern. And I think it has to do with it. Oh, I have to read that. Oh, it's a book title. All right, let me write that down. I wrote down the other one. Math rules and laws. Okay, I'll take a look. It's just interesting. But see, that's the thing. I don't think anybody's really talked about elementary school math. Like, it needs to be a system. There's a pattern to it. There's a pattern to it. And they kind of buffooned it all. You know what I mean? Okay, I gotta stop. I'm gonna start crashing out. Okay, so here we are. We're gonna be adding the 5. When we add the 5, all we gotta do is add to the horizontal bar. That's what we're doing. Add to the horizontal bar. That's what we add the 5. So we can do it again, right? We can do the 6. Well, what's a 6? adding the 6 is plus the 5 plus the 1. That's what 6 is. Plus the 5 plus the 1. That's what 6 is. Now, guess what? Well, what happens if there's already a number here? Oh, I want to add 6. To add the 6 is plus the 1 plus the 1 plus the 5. And then we have System of Abacus would be an interesting book. Oh, LD. It would be interesting. Yes, all right. There are a couple of books, but they're not, it's a hard read. Reading Abacus is a very hard read. I think just reading is just a hard read. I could try, but I don't know if I don't know if there's enough, I don't know if there's enough pages to make a book out of it. You know what I mean? Because I just go on these rants and I just kind of understand, and then that's it. Poof, it's gone. Maybe I'll think about that. Maybe I'll think about that. So we have it again. We have 7. Notice 7 is 1 bead on top, 2 beads on the bottom. But if I already have a number here, well, I want to add 7. To add 7, again, it's what? 1 bead on top, 2 beads on the bottom. It doesn't change. It doesn't change. So guess what? If I want to take away 6, 1 bead on top, 1 bead on bottom, and you take it away. Now what we're doing is we're understanding how to subtract. What is subtracting? Subtracting just means take away. What's the problem? The problem is in mainstream school, they give you this concept of subtraction, but they don't show you. Whereas in Abacus, you can see it. You can see that there's an adding, and you can see that there's a subtraction. So we add 6. We take away 6. We have 2 on the Abacus. So let's do 8. When we do 8 on the Abacus, right? 8 is what? 1 bead on top, 3 beads on the bottom. That's what 8 is. If I have 1 already, to add the 8 is what? 1 bead on top, 3 beads on the bottom. And you add 8, my final answer is 9. Guess what? To subtract, what do? Minus the 5, minus the 3. Minus 8 looks like that. That's all we're doing. Thank you everybody for joining. Thank you everybody for joining. So we're adding the 8, we take away the 8. You know how to add, you know how to subtract. Oh, LD, now I got this book in my head. All right. I'll have to see if I can figure out how to formalize it. And then that's it. So we are here, and we already know how to subtract. Why? Because if you know how to add, right, this is 8. I want to subtract 7. Subtract 7 is 1 bead on top, 2 beads on the bottom. Subtract the 7. So my final answer is 1. Make sense? So what we're doing is we're understanding how to move the beads. What happens when there's not enough? What happens when there's not enough? That's when we have to start using formulas. Oh, before I forget. That didn't sound good. Hold, please. Huh. That was really strange. Hold, please. I'm going to go check my yard. Thank you. Ha, thank you, Yukon. So one of them was like, we have to get the kids to memorize how to make a 9. Abacus world, we don't need to memorize how to make a 9. Because if I have the 1, right? If I have the 1, I want to add 8. Guess what? I add the 8. That's what it is, right? If I have 2 on the abacus, and I want to add 7, I know what 7 is. 7 is 1 bead on top, 2 beads on bottom. Add the 7. Guess what? If I have 3 on the abacus, I want to add 6. I have 6. We don't need to memorize how to make a 9. That's what I'm trying to say. The only thing we need to do is we need to understand how to make a 10, and we need to understand how to make a 5. Those are the only 2 things we need to understand. Okay? So, we're done with that. Well, now, what happens if we don't have enough? All right. What we need to do is we need to go into how to make a 5. How to make a 5. How do you make a 5? How do you make a 5? This is going to be super easy. Abacus world, no, mainstream world, we have to, you're told to memorize. But in Abacus world, we don't need to memorize. In Abacus world, what we do is we understand how to make a 4. So we have our abacus. I want to add the 4. You can add another 4 here, but that's not what we're doing. You know why? Because that's the 4 tens. This has become 44. We do not want 44. What we want is we want to be able to add the 1s over here. So we add the 1s over here. What do? We don't have any more beads. We can't add any more 1s there. So guess what? I'm going to do 4 1s. I'm going to do 4 1s on my abacus. There's my 4, right? There's 4. I want to add another 4. Add another 4. There we go. So in mainstream math, what do? Is they just say, okay, you know what? We're just going to bring it all together and you're going to add it. 5, 6, 7, 8. So you count up. But in Abacus world, we don't need to. In Abacus world, what do? We're going to round this and we're going to regroup to make it a 5. We're going to regroup this one to make a 5. Well, how do we do that? We know if we want to add 1 to make a 5. That's what we need to do. 4 plus 1 is equal to 5. We got to get the 1 from somewhere. The 1 comes from the first number. The 1 comes from the first number, like here. Okay? Because it comes from the first number, we got to give it away. So we take away from here, and then we add it to the bottom number. We now regrouped, and we made a 5. So my final answer is 8. 5, 6, 7, 8. 5, 6, 7, 8. So what we're doing is we're understanding how to regroup at a smaller level. We can do it again. We can do 3 on the abacus. I want to add 4. To do that, what do? I need to make a 5 here. To make a 5, that's the pattern. I need to add 1. To add 1, what do? I got to take away from here. So you have to subtract in order to add. Now, and then I added, I make a 5 here. So my final answer is 7. 5, 6, and then 7. Add the 5, take away the 1. So my final answer is 7. So just like how you drift.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Right? You turn right to go left. So just like we need to subtract in order to add. Thank you. It is 7. So we have our next number, right? We have 4 on the abacus. Hello, board. Hello. Thank you so much for checking in. So we have 2 on the abacus. We have 2 on the abacus. When I want to add 4, guess what? I need to have plus 1. Plus 1 has to come from somewhere. To make this a 5, 1, 2, 3, 4, 5. We need 1 to make a 5. To get the 1, it comes from the first number. You minus the 1 from the 2. Minus the 1 to make a 5. So we regrouped and we made a 5. So our final answer is 6. Thank you, Estella, for the rose. Thank you so much for the rose. How are we doing? Make sense? We're going to keep going. We have 1 on the abacus. I have 4. Notice there's no more room to add the 4. There's no more room to add the 4. How long have I been on? Oh, I've been on for an hour and a half. Yeah. Oh, Ken, have you been doom scrolling too much? Is your brain hurting? So instead of counting up, we're going to use concepts, right? So thank you, Treble, for the share and the follow. This is one of the concepts. We're teaching the kids to do this, so we're making this concept, right? We're utilizing this concept. When we utilize the concept, right, we're going to understand. So we do it again. If I have the 1 over here, I want to make this a 5. We're going to regroup. My brain hurts, but it's not because of doom scrolling. Right? So what we're trying to do is what? We're trying to round this up to 5. To round this up to 5, I got to take away the 1. And now I've made a 5. Right? Now I've made a 5. So my final answer is 5. And we could do it again with a 3. So we have 3 on the abacus. Hello, Yukon. This validates I've done my... Oh, yay! Oh, yay! That's fantastic! That's awesome, right? I'm not completely crazy, right? Yeah, you're not crazy. You're not crazy at all. Yeah, I got 100. Yay, Lemon! Well done. So we have 3 on the abacus. 4 on the abacus. We have 4 on the abacus. What are we doing? We want to add 3. To make a 5, what do? 3 plus 2 equals a 5. 3 plus 2 equals a 5. We got to get the 2 from somewhere. The 2 has to come from the previous number, right here. So we got to take away 2 to add to here. So we take away 2 to add to here, we now made a 5. So my final answer is 7. So we plus the 5 and take away the 2. So my final answer is 7. Yes, thank you, Wheels. Thank you. Add the 2. Thank you. Yes. So we could do it again. You know 3 plus a 3. How do you do it? Thank you, Erin. So sweet seeing you be passionate about math. Yes, I am very passionate about math. I'm very, very passionate about elementary school math. 6. Take the top one. Yes, thank you. Take 2 away and then add the 5. Thank you, Wheels. That's what I'm looking for. You have to take away 2. Thank you, Sophie. You got to take away the 2 and plus the 5. That's what I'm looking for. I'm not looking for the answers. I'm looking for how did you get that? You know what I mean, Unique? I want to know how you got it. Because these questions are super easy. These questions are not meant to be hard. These questions were meant to show you a concept. Add the 1. There is no 1. Add the 5. This is 5, not 1. The top will always be 5. The top will always be 5. Yeah. Okay, how are we doing? Make sense? Alright, we're going to keep going. Wait. What am I waiting for? Do you add the green to the blue? No. So how would you 3 plus 1 plus 1 plus 1? Sophie, in this example, you take enough from the top number to make the 5 and then continue. Yes. So the question is, I have 3 plus 3. The first number, the top number is 3. Yes, you take the 2 away from the 3. You take the 2 away from the 3. You add the 5. Yes. And then you get your final digit. Yes, that's how you do it. Thank you, Jim. That was an easy question. Because why? Because we have 3 plus 1, right? We have to add another 1. We have 4 in the abacus. We have 4 in the abacus. I want to add the 1. To add the 1, what do? We know that we need to make a 5. To make the 5, we need to get 4. 4 has to come from somewhere. 4 has to come from the previous number. That's where we get this from. 4, that's now 5. So we add the 5. And then we add the 1. That was the question. Is this based on of Common Core? Oh, thank you, Yukon. Thank you, Yukon. Thank you, Yukon, so much for everything. Thank you so much. I appreciate that. Thank you, Yukon. Is this based on Common Core? No, Wheels. This is based on Mesopotamia. This was before Common Core. The abacus has been around since the 16th century. Is the base of hello applesauce. The abacus is the 10 base. Thank you. It's been fantastic listening to you teach this evening. Oh, thank you so much. Thank you so much. I appreciate that. It was just one of those things, like I was just going down the rabbit hole of like philosophizing about, why American math is broken. Good morning. Good morning.
Step 2, greet the day, smile, and say, Good morning, city!
My dad told me because he wanted to open a learning center. I learned Abacus late. I learned Abacus when I was 30. And so, thank you, Nova, for the rose. And so, my dad wanted to open a learning center because he wanted to build something for his retirement. So he told me and my brother to learn the abacus. He didn't learn the abacus. I had to learn the abacus. What she teaches is the basic. Learn the rules. Oh yeah, right, Mio? Yeah. Nice workbook. Oh, thank you guys. Oh yes, thank you. And so you're not 30 now. I'm not 30 now. I'm not 30. I've been teaching for 30 years. I'm sorry. I've been teaching for 20 years. So there's my age. My boys, I made my boys learn because I realized that learning abacus is a really good thing, and they have a really good sense of numbers, and they have a really strong foundation. I didn't have to teach them math when they went in school because they already knew how to do the abacus, and they just used the abacus to leverage off what they were teaching in school. Yeah. So, she has kids, still look. It's a filter. TikTok provides filters. It's also the attitude too, right? Like not everybody acts young. Like I act pretty young, I think. I'm a little bit immature sometimes. But that's why I like trolls sometimes, because it keeps me on my toes. Can we switch to a bigger one? I agree. Yeah. Can we switch to a bigger one? Bigger one what? Bigger number? Why not love? Why not? Yeah, right? Why not live life? Yeah, totally. What? Nova? Sidebar, are you still a dev? Not. I want to get back into it, but I don't have the time of day right now. I want to get back into web dev. I started following Allie. I don't know if you do web development, but I started following Allie, and she's doing beginning parts of Python. Switch to a bigger abacus? Like this one? Or are you talking about the Chinese abacus? Yeah. She does beginning Python, which really inspires me to learn, but then when I try to go back to it, I'm like, I'm trying to build this business. I don't have that time right now. Right. So when we're looking, I'm using this as my ones place, right? Because I have my ones place here, then I have my tens. I'm sorry. I have my comma. My comma is my thousands and my hundreds. I'm sorry. Thousands and millions. So every comma, every grouping is my place, is where the comma is. Ones, thousands, millions. If you wanted to, 10,000 would look like this. That's what 10,000 would look like. You could do it here too. I'm sorry, that's not 10,000. If I do ones, thousands, 10,000, that's what it looked like. You could do it on this one too. 10,000, you could still do it on the big abacus, on the small abacus. That's what 10,000 is. But the difference is, if I want to do 100,000, I cannot do 310,000 on this abacus because I have no more room for it. And then I can do millions over here. So this would be 9 million. 9,310,000. So, yeah. Yeah, that's what I noticed. Like, I want to get back into web developing, but I was actually looking into figuring out what do I want to put into a mobile app. A mobile app. But then that's a whole lot of thinking. And it's just me. It's just me. Can big number add exercise? Can big number add exercise? What do you mean? What do you mean by big number can add exercise? Yeah, and then building out the books, teaching, going live, getting getting Abacus out there, trying to work the market. I don't have time right now to go back to web developing. I wish I did, but not right now. Not in the beginning parts. That's why I asked. You have the skills set to create a legit app for learners and parents. Yeah. Yeah, I was looking into it. But then I have to take some time to learn. I got to take some time to figure out what I want to create. Can excess be a big number? I don't know. Sorry, can we do a question with triple digits? Oh, yes, we can. Hearing the abacus being clear. Yeah. Oh, hey, Allie. I was talking to her about that. Oh, that's interesting. It is time consuming. Yes. Hey, JJ. I'm going to bed early. You're finished with your live? Triple digits. Yeah. It's one thing, it's time consuming, and trying to figure out how to I have been thinking about an app, but the problem is I don't know how I want to shape it yet, which is really interesting. I have low energy today. Oh, did you go like two? Yeah, two. No, you know what? Going 2.5 hours going live, that's draining because you're always presenting. And you don't see, you don't know, but it's a lot of energy. I actually take naps after my lives because it's such an energy drain. Yeah. I don't know if you want to maybe go for you can't pick your nose. I can't pick my nose. I can pick my nose and you won't know. You might want to try to go for a walk before you go to sleep. I was going to do that, but then it gets really hot when I anyway. So I think I'm going to go to walk after this. See if that works. Okay. Have you gone? I'm excited. I love excite while you teach. I might go for a short walk. Yeah, go for a short run at the gym. There you go. Okay. 3 digits. I don't know what this number is. I don't know what we're doing. That'd be good. Go to the gym. Did I go to the gym? I did not. Oh, but I have been working on the kettlebell. I love how excited you get while teaching. I do. It's so funny, Ebony. Like in the beginning, before I click on live, I was like, I don't know if I want to go on. But then once I start, it's just amazing. The kettlebell is hard. Oh, I like the kettlebell. Mine's a 25-pound kettlebell. You should try it. You know what though? You need to lift weights. Just in general, you need to lift weights. I don't know if you could see that. 5 to 6. 5 to 6. It is fun to go live. It is fun to go live, but it is very draining. We want to add the 1. We want to add the 0. And then we want to add the 4. How do we add the 4? Pre-anxiety. But you're awesome. Pre-anxiety? Oh, really? There's no need to worry. Heading to the gym. Okay, see you later, Allie. Thank you. Have a good day. Have a good... Oh,
Oh, and in case I don't see you, good afternoon, good evening, and good night.
all right. How do we add the 4? I want to add the 4 here. How do we add the 4? You got to build out your sound bites for like starting the live, man. Oh, I see. Yeah, I'm slow. Yeah. It's just one of those things, but once I get going, then it's pretty good. But then it all depends if I've had enough sleep too. If I don't have enough sleep, then I get really tired real fast. So, but I think yeah. So when we add the 4, what do we do? What do I need? I need my paper. We want to add the 4. How do we add the 4? Plus the 4 is what? Do we know how to do it? There's no more room to add the 4. There's only 3. 1, 2, 3. Remember how to add the 4? We can add the 4 with the 5. Can we do that? No, we can't do that. No, we can't. We cannot add the 5 because we're already using it. Guess what? What's the other one? 6. This is why. Yes. Plus the 10 minus the 6. Yes, Ebony. Well done. Plus the 10 minus the 6. So my final answer is... What's my final answer? Plus the 10 minus the 6. What's my final answer? So we have our number. That's our question. What's our answer? How do you add... Okay, let's get to that in a little bit. Ha ha ha. See, oh, when you get to the workflow, you'll understand. Thank you, Ebony. 630. Yes. That hurt my brain because I was reading from right to left to right. It's not. I just got back. Oh, hey. Thank you, 630. I got lost. Okay. I just got out of work. Oh. Okay. The question is 8 plus 9. 8 plus 9, right? Well, how do you add the 9, Sophie? How do you add this 9? Same thing. There's my 8. I want to add the 9. How do you add the 9? You know how to make a 10. So if we want to add the 9, we got to take away the 10 from somewhere, right? We got to take away the 1 from somewhere. The 1 will come from the previous number. Take away the 1. We've made my 10, and I add the 10. And so my final answer is 17. 17. 17. 17. Cool. Yeah? Makes sense? Why would that hurt your brain? Oh, I see why. Because you said it's the other way. Well, let's do the other way. All right. Let's do the other way. It's still going to be the same if you really think about it. Right? So if we did 5 to 6. So we do this first. Plus 4 is equal to plus the 10 minus 6. Plus the 10 minus the 6. And then plus 1. Plus 1. Same. No difference. Actually, there is a difference. It just works better if it goes left to right. It's just funny. Cool. Hello, Cosmic Light. Hello. Thank you for the follow. Hello. Welcome, everybody. Welcome. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
They're all the same. It doesn't matter. It doesn't matter if you go left to right, right to left. Actually, it does. I feel like left to right is easier. It just flows better if you go left to right. Then we can do another one. My professor used to say it's always like this except when it's not. This is another alt for... Oh my goodness. Okay, crazy train. Turn left. Yeah, right? Turn right to go left.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
That's what I kept thinking in my head. It didn't match, so I was glad it worked. It worked, so I can be calm. I can be calm. Ah. Crazy Train, how many usernames do you have? You're so funny. That's all right. I think I have 3. Ooh. And the original Crazy Train. That's funny. You have 3. Those are really clever names. I just want to let you know. I am so bad at trying to create names. Yeah, I'm really bad at creating names. I like your Crazy Train one. Is it Crazy Train because of Ozzy Osbourne? That's funny. All right. We can do another one. We'll do another 3 one. I don't know. I've just been kind of all over the place. All right. We're going to do this one. I don't know if you can see that. 328. I want to add 9, 4, 1. Add the 9, add the 4, add the 1. Add the 9. How do you add the 9? Is there any room to add the 9? There's no more room to add the 9. Yeah, it's my Xbox user name. It just stuck. Oh, that's cool. That's better than... No, right? That's better than... Stanky. Yeah. Anyways. Okay. Subtract the 1. Yes, thank you. Right? So, to add the 9, we have to plus the 9 equals to plus the 10 minus the 1. Plus the 10, nope. Plus the 10 minus the 1. That's what we're doing here. I don't know if you can see that. Plus the 10 minus the 1. That's what we're doing. So then we want to add the 4. We're going to add the 4 here. Add the 4 is what? Can you add the 4? No. There's no more room to add the 4. What do we got to do? We got to utilize this 5. We can round up to 5, right? So 4 is equal to what? 4 is equal to... Thank you, Ebony. Yes. See, you're getting it. You're getting it. Is equal to plus the 5 minus 1. So you plus the 5 and you take away the 1. And then you add the 1. Thank you, Wheels. Exactly. And then you add the 1. Add the 1. So what's my final answer? Can you read that? Where it's a 4-digit number. We have ones, tens, hundreds, and then thousands. 1,269. Yes, thank you. Thank you, Ebony. Thank you, Wheels. Thank you, LD. You got me wanting to learn this. Hello, Steph. Thank you, Cosmic. 1,269. Easy. Simple to use. Easy to understand. I'm just kind of loopy today. I don't know. I don't know what's going on. Hello. Hello. Hello, Steph. So, I don't know if you know how to read this. Go left to go right. Yeah.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
I'm sorry. Yeah. Left to right. Left to right. Because we don't say 9, 60, 200, 1,000. We don't say that. So, it's 1,269. So when you're looking, Steph, just so you know, the top beat is a value of 5. This is the top beat, right? This is a value of 5. These ones, the top beat is not touching, so this is considered 1 and 2. This is 6 because the top beat is touching. The top beat is a value of 5, so this is 6. If I add that, right? If I add that, that'd be 6. But it's not. It's 1,269. If I take away the 5, this would be 14. 1 and 4. 12, 14, right? 1,214, but it actually had these ones. So this is 1,269. That's what that is. We're reading it. Now you might be wondering, well, why am I here? I'm here because I have a label. That label tells me this is the ones place. So my ones, my tens, my hundreds, my thousands. There's another label here. This is where my comma is. The comma for my thousands. It's like a grouping. Yep. Yep. All right. How are we doing? So LD, so those are some of the questions. Those are some of the answers in the book. That's funny. So that's the book. We're doing the book. Yeah. I don't know. I want to do the other book. But it's really a little bit more advanced. There's this one. I don't know. I don't know where I'm going to put this one. I kind of like this format. But I think what I want to do is I have the question, I put the formula, and I get the answer. Oh, excuse me. All right. So for those of you that are interested, this is a Abacus book for adults. We do adding, subtracting. We build confidence, promote critical thinking. Critical thinking because we actually utilize two concepts. The one concept is how to add the 5, and the other one is how to make a 10. And then towards here, you start figuring out how it's being used. And this is where you Tetris your way through. Yep. So then if you know how to add, you know how to subtract, and then I give you all these activities to strengthen the concepts of adding, subtracting on the abacus. This is all abacus focused. It is this abacus. The abacus is a soul roll bond, which is a Japanese abacus. This Japanese abacus will help you become stronger at math. And you know, funny, the more you know, the more you can't not see it, which is really funny. So, yeah. And then, do you have answers in the back of the book? Answers in the back of the book. Oh, yeah. Yep. Cool. How are you doing? I think I'm about done. Anybody have any questions? What are we going to talk about? What are we going to talk about? Anybody have any questions? We have 220 people in the room, and it's just like 5 of us talking. Anybody have any questions? How are we doing? Oh, yeah. Okay. That was the other thing. Maybe I'll work on the book. So the book, I was going to do multiplication. Nobody have any questions? Sad panda. Would you rather do... I know we're not there yet. We could do a multiplication question. The answer is abacus. Applesauce, you're funny. Yeah, we could do multiplication, and then we'll be done. Because what I want to do is... Okay, there would be 2 times 9, 9. Or there would be 9, 9 times 2. I think it'd be good. Sorry. Okay, I was just trying to figure out like how I want to set up the questions. So I was going to do I forgot this I forgot the word. The word is... That's not the word. Commutative. That's what it is. Commutative. Commutative property. Property. Yeah. All right. Maybe even a division question. I don't know. Let's see. So we're gonna count 1, 2, 3. Sorry. 1, 2, 3. Distributive property is 8 times 9. 9 times 2 is equal to... What's 9 times 2? 9 times 2 is equal to... You know what? Wheels. If you can get me to 60,000, we can do division. How about that? Thank you, Wheels. It is 18. Add the 1, add the 8. And then we do it again. So notice I don't need to say 90 times 2 is equal to 180. We don't need to do this because our abacus does it for us. Oh, a challenge? If I can get to 60, yeah, we'll do division. 130. We get to 60 in 1 minute. 70 in 3 minutes with tapping. That's if everybody tapped, and not everybody understands the tap. That's very optimistic, but I know that's not the case. So, oh, and then we add the 1, we could do it again. We got to do 9 times 2. 9 times 2 is equal to 18. We add the 1, we add the 8. So our final answer is 198. Did that make sense, LD? So I think what I was going to do is I was going to do 2 ways. 2 times 9. 2 times 9 is equal to 18. And then do that again. You know what I heard? One of my friend mentioned that they actually don't need to memorize 12 times table anymore, because they're starting to realize that they do distributive property. But they still have to go up to 10. But I'm like, why? That's still redundant. It's funny. So, yeah, I think that's what I'm going to do. And then there's going to be a bunch of 2 times table. And that would be the first set. That would be first set of mazes. What do I have to do? I have to figure out how to formalize my multiplication book. Yeah. Okay. So then we could do another one. Let's do another one. Okay. Here we go. We're waking our way up. Yeah. Yeah. I'm trying to figure out, like, we'll do 70 times that by 2. Again, what are we doing? We have to figure out a number. 1, 2, 3. 1, 2, 3. 7 times 2? 7 times 2. 7 times 2 is what? 7 times 2 is... Thank you. What is 7 times 2? 7 times 2 is... 14. Add the 1. Add the 4. Right? Then we do 2 times 2 is equal to 4. 4 is a single digit. So what do? We have to make this a double digit. Make it a double digit, which is a 0 and a 4. Right? Because it's a 0 and a 4, it pushes it out. 0, 4. So our final answer is 144. So that's our answer. 144. Cool. Thank you for the follow, Kesha. And then we can do another one. We can do 7 times 7. 77 times that by 5. Same thing. 77 times by 5. It's 3, right? 1, 2, 3. 1, 2, 3. 7 times 5 is 35. Add the 3, add the 5. Do it again. Add the 3, add the 5. So our final answer is 385. That is our final answer. Hello, Carlos. Hello, Carlos. How's it going? Oh, kids are home. People are home. All right. and people have carpal tunnel syndrome. All right. So we have 385. So that's what we're doing. I think that's it. One more time, please. Okay, let's do it again. We're going to count the amount of digits. 1, 2, 3, right? Why? Because we have 3. 1, 2, 3. 1, 2, 3. Oh, can't see that. Hold on. There we go. Right? So 7 times 5 is 35. Add the 3, add the 5. We're over here. Yep. Then do it again. 7 times 5 is 35. Add the 3, add the 5. Add the 35, and then do it again. Add the 35. Yeah. Easy, right? Simple to use. Multiplication on Abacus is really easy, because you can see the numbers. Thank you, Jessie. Jess. So we could do another one. Let's do one more. Okay, we could do that one. 57, 57 times that by 5. I dropped my phone. I'm gonna say Hi.
Hey.
What is this?
A hamburger.
Oh my goodness.
It's National Cheeseburger Day, so it's a double cheeseburger.
Oh, and that's what you guys went?
Yeah.
You guys went to McDonald's?
It was only 50 cents.
Oh my gosh, that's funny.
Yeah, I didn't know if you had dinner, so.
Thank you.
I didn't know if you'd be too lazy to make dinner.
Thank you.
Alright, yeah, that's a little snack.
Thank you for the snack.
No fries, no.
Ah, sad panda.
It's not National Friday.
Sad panda.
Bye.
Bye. Are you leaving?
No.
Okay. Thank you, Jess. McDonald's 2 for $1 deal. Yeah. Yeah, because today is National Hamburger Day. Buy one. Oh, hey. Oh, sorry. You just heard the whole conversation with me and my kid. So we do it again. 3. 1, 2, 3. Thank you, Jess. I appreciate that. Easy. It's not hard. It's not hard. The only thing is you need to know your multiplication fact, right? And so we do 5 times 5. 5 times 5 is food. What's that? 5 times 5? 5 times 5 is 25. Add the 2. Thank you, healing, not healed. Okay, good. Healing. Good to heal, though. 20 and then 5. Right? 25. We're not going to do 50 times 5. We don't need to do that. Why? Because we have the abacus to help us. Keep our track in our numbers. We have 250. Do you see that? 250. So then we do 7 times 5. 7 times 5. What is 7 times 5? What are we doing? Because we're doing this. 7 times 5. 7 times 5 is... What's 7 times 5?
Bueller.
35,
Bueller.
thank you.
Bueller.
Thank you, Ebony. Thank you, Jess. Yes, it is 30. It is 5. So our final answer, can you read our final answer? We have our hundreds, our tens, and our ones. What number do we have? And we've reached 60. So we're going to go into some division. $285. Thank you, healing. Right? 285. Thank you, Scumpet. 285. I did it in my head. Okay. Good. I'm happy you did it in your head. But I'm just teaching you a concept. That made it easy, right? That's what I'm saying. My fingers, thank you for notifying the goal. Yes, thank you. Daily hearts covered. Thank you. Hey, welcome back, DeSelly. I love this. Who created this? I don't know who created it. Some random person. I'm good at math, terrible in writing essays. ADHD. Okay. I see it. Thank you. Oh, good. Yeah. So when you're looking, the abacus helps you visualize the numbers. All right. So I guess we're going to do some division. All right. We'll do some division. I'm going to move my stuff. Where am I going to get my paper from? Oh, I know. Let's see. All right. I've only seen one example. Oh my god. All right. Let me see if I can. You know what, Wheels? I have a post that I did on division. Am I a math teacher? I am. Because I'm teaching you math right now. We're doing math. Did you see my post of division? I don't remember where it is. I think it's like recent. I think I did it like a couple of days ago. Yeah. All right. Da, 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 da. Okay. I have a vintage abacus. That's cool, Constance. But question is it 2 beads on top or 1 bead on top? Or is it a 10 bead? Because a 10 bead is also vintage as well. I don't know what vintage means. Okay. I looked for it when I'll look for it when I was here when you did the example Tuesday night. No. But there's another one. I actually made a post because another TikToker was asking me if this is how they do abacus on the division. 6, 3, 8, 4. Hello, Redux. Yeah, I'll look for it. Okay. I'm teaching you abacus. I'm teaching you how we do it on the abacus. I'm teaching you concepts. So if you could do it in your head, great. But that's not what I'm teaching. I'm not teaching you how to find the answers. I'm teaching. Hello, Ashley. Hello, Redux. Hello. Hello, everybody. Welcome. Welcome.
Welcome to the real world.
Do you have any bubble gum?
I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum.
No. Nuts. All right. The first thing we're going to do is we're going to understand where are we going to put our quotient. They live. I know, right? You know that? Yeah. That's pretty good. That's pretty good. Applesauce. That's pretty good. You know this one. Do you know this one?
Hey, it's a little too early for being that loud. Hey, too late. It's 0600. What's the O stand for? Oh my God, it's early.
I look as old as I am. You look like a millennial. No. Oh, yeah. Cohen Hour? No, it's Good Morning Vietnam. I don't know Cohen Hour. This is Good Morning Vietnam with Robin Williams. Okay, so we're going to figure out where we're going to put our quotient. To figure that out, we have our dividends. We have 3 dividends, right? 3 digits in our dividends. 3 digits in our dividends. And then what do? We have to subtract the amount of digits in our divisor. So we have 1 over here. So 3 take away 1 is equal to 2. So our starting point will be in the tens column. That's how we figure it out. This is where I'm going to put my quotient. My dividend will be here, 384. All right, now what are we going to do? We're going to figure out a few things. In Abacus world, we don't say how many times does it go into whatever. In Abacus world, we do missing factors. 6 times what is equal to 3. The 3 comes from here, right? The 3 comes from here. The 6 comes from here. When we're looking, is there a multiplication fact that does this? No. So what do? We need to make it a double digit. This is why we need to make it a double digit. We need to make it a double digit because there's no 6 times what is equal to 3. So to make it a double digit, what number do we have to bring down? What number do we need to use to make it a double digit? What number do we need to use to make the 3 into a double digit? 8. Yes, Mio. It is 8. It is not 6. It is 8 because it's this one right here. The 8 goes here. So this 8 goes to there. Thank you, Healing. Thank you, Jess. Thank you, Mio. Thank you, Wheels. Right? 6 is our divisor. You don't need to do the divisor. You need to do the dividend. So this is my dividend, right? Bring down the 6 for 36. It is not 6. It is 38. We now can do 6 times 6 is equal to 36. We don't bring down the 6. We don't bring down the 36. We take away. So you add the 6 to your abacus. This is my quotient. I added my 6. Here is my quotient. Here is my quotient. I add the 6. Now, I have to take away 30, take away 6. Take away 30, take away 6. Take away 3, take away 6. Hello, board. Now what? I still have dividends. Still only compare one number. One number. This is the number I'm going to use. So my question is what? 6 times what is equal to what number? Hello, Mason. What are we dividing? 2. Exactly, Wheels. 2. Can we do it? 6 times what is equal to 2? We can't do it. We need to make it a double digit. How do I make it a double digit? It needs to come from, what number do we bring down? It's quite obvious is incorrect. Here's my 2, bring down the 4, right? Make it a 4. Yep, make it a 4. So, what do? 6 times 4 is equal to 24. This 4 is my quotient. So, I put my quotient here. Take away 20, and then take away the 4. So my final answer is 64. Thank you, board. We were doing this question. And my answer is 4. 6. So what we do in Abacus world is we go find the missing factor. We don't do how many times is it divided into. Yeah. That's how we do it. My mind is going, that's crazy. Is it simple? It's a little bit different, right? It's unfamiliar. It's a little bit different than mainstream. But this is how we do it on Abacus. We do long division. Foster is very interesting. It is simple. Yeah. Yeah, because we only need to look at the two numbers, and you now know why you bring it down. Do you see why? This is crazy simple. Once you know the rules, yes. And yes, with the terminology, yes, exactly. Phosphorus is very interesting. That's pretty interesting, board. Not that I was taught, the way I was taught was so confusing. Yeah, I literally could cry. Oh, my dad was awful to no. It's, because we didn't learn how to divide. When we were kids, we were never taught to learn how to divide properly. I learned the abacus, and I'm like, this is crazy. I can't believe how abacus makes it so easy. So that's the thing. We can do another one, and it's all the same process. Thank you. I had to present in front of. It was scary. Board, you do it often enough, it won't be that scary. Do another. Okay, Wheels. So this is, if you're finished if you're finished, how do you multiply? Because even if I follow the steps, I get it wrong. Lasagna, let me know what question it is. Where did you get the 2? It just popped in. I got the 2 from when I subtract. Seriously, can't wait to show my kiddo. He's struggling with math. Oh, interesting. Have a good night, board. I'll see you later. Have a good night. Have a good night, board.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Yeah. So we took away, we had 38, and we took away 36. We take away 3, we take away 6. We're left with 2. That's where the 2 comes from. Truman. Yes, you're right. Truman Show. Oh, how about this one?
No, now go away or I shall taunt you a second time.
Yeah. So the question was 384. So we had 384 on the abacus. So we took away the 36, and then we took away the 24. Monty Python. Well done, Wheels. Well done. What else do I have? You know this one. Okay. All right, let's do another one. Okay, we'll do another one. We do 3 divided by 141. Sloth. Yes! You're well done. Well done. It is Goonies. Well done, Jess. All right. Oh, okay. How about this one? All right. Do it again. SpongeBob? No. No clue. This one was Sesame Street. There was aliens that came down, and they didn't know what a telephone was, and they were like, "Bing!" Yeah. All right. Thank you, little one. We're not here to answer. We're here to understand. So, the first thing we're going to do is we're going to figure out how many digits we have. We have 3 digits here. So, 3 digits in our divisor. You minus 1 digit from our dividend. So we get, what do we get? We get our place value. So our place value, oh, I should do it the other way. And then this is small d. It's a good one. Big D, small d. Okay, so we have 2. So we are going to put our quotient in the second column over here. We're going to put our dividend on the abacus. We add 1, 4, 1. I like the big D and the little d. I think the big D and little d sounds good. I think the big D should be the divisor and the little d should be the dividend. That's what I'm thinking. Hey! Hey, yo. Yow, J. Okay, so, wait, we're never going to use it again. What are we going to do? We're going to figure out single number. This number and this number. Why? Because we got to figure out 3 is our dividend, or is our divisor, times what is equal to 1. 1 is our divisor. 1 is our dividend. 3 is our divisor. So I'm trying to line it up so it makes sense. You cannot, there is no multiplication fact for this, right? So if there's no multiplication fact for 1, what do? We have to make it a double digit. To make this a double digit, what number are we going to put here? Bring down the 4. Yes, we're going to make it a 14. So thank you. The 4 comes from here. So now the question is what times 3 is equal to 14 or less? What times 3 is 14 or less? What time? Yes, thank you. 4 is equal to 12. Right? So, hello, Jess. Want to say hello, Jess? Welcome. Hi. See you later. So now, 4 is my dividend. 4 is my dividend. I add the 4 here. Right? And I take away 12. I take away 1. And I take away the 2. Does that make sense? So now we're left with what? Now we're left with 24. with 2 and a 1. But again, we only want to compare the 1 first. We only want to figure this out. So the question is what? 3 times what is equal to 2? That cannot be done. Thank you, Beto. Yes, thank you, Beto. Right? You cannot do 2. So what do? You got to make this a double digit. What do you bring down? No, not the 0, because it's not 0 here. What number is that? You got to make this a double digit. Bring down the 2. Bring down the 1. We got to make it a double digit, right? There's a 2 and a 1, so it becomes 21. Thank you, Wheels. Yes. So, right. Thank you, Lasagna. We bring down the 1. So what happens? What times 3 is equal to 21 or less? 7 times 3, right, is equal to 21. Add the 7 on the abacus. That's my quotient. I have my 7 on the abacus. I take away 20, and I take away 1. I take away 2, and I take away 1. So my final answer is 47. So my answer is 47. Yeah. So this is the question. I don't know if you guys can see that. So this is all we did. We just figured out how many times it goes into multiplying. So in Abacus world, we figure out our missing factor. Got it? Oh, good. Good. Easy, right? Simple to use. Simple to use, easy to understand. Thank you. Thank you, Jess, so much for this, for the hearts. Thank you so much for the hearts. Ah, you're so kind. We got to 61 because they wanted to do division. I just checked the calculator, she's correct. Oh, thank you, Lasagna. Hello, Merc. Hello, Merc. Hello. Hello.
Welcome to the real world.
Yeah, use a calculator. Welcome. And yes, I saw that. Yeah. And I gotta, yeah. So what we do in Abacus is we find the missing factor for our multiplication. That's what we do. We don't use the terminology how many times does it divide into, because that's difficult, because we don't have a division table. If you ever notice, everyone is so awesome. Yeah, everybody is awesome. Oh, I don't have it. Oh, I do have it. I have it. I have it. All right, we'll do one more. It's just my third day of learning. I'm kind of correct, though I'm not good enough. It's a Lego movie. Yes, thank you. One more. Yes. Is that division? Yes. What is division? Ah, thank you, Jess. Yes, thank you. Thankfully, there is no division table. Learning the old multiplication. Yeah, and that's the thing. We, in Abacus world, we only need to go up to 9 times 9. So in Abacus world, we only need to go up to 9 times 9. That's it. Because then everything else after that is just redundant and repeated addition. Not repeated addition. Distributive property. 1, 4, 8. I know you can do this. I know you can do this in your head. I'm showing you a concept. That's my caveat. I know this is easy. It's meant to be easy because I'm showing you concepts. I'm showing you because once you get this, then the bigger the number, it doesn't matter. We haven't started yet. We're going to count our dividends, right? We'll call it small d. 1, 2, 3. We got to take away one big one, 1 big D is equal to 2. So we have 1, 2. This is where our quotient's going to be. So we're going to add the quotient 1, 4, 8. Thank you, Chubacoca. Okay. So what are we going to do? We have to do 2 times what is equal to 1. Remember, this is where the dividend is. This is where the divisor is. This is where the dividend is. Is there a way to do 2 times what is equal to 1? No. There is no multiplication fact for that, right? So we got to make it a double digit. How do you make it a double digit? Thank you for checking in. Thank you for the heart me. Thank you, Jess, for the heart me. I appreciate you. Thank you so much. So we got to bring down the 4. So the question is 2 times what is equal to 14? Thank you. It is 7, right? So we add 7 to the abacus. We add 7 to the abacus. I want to take away 1 and then take away 4. Okay? So when we want to take away 14, what are we left with? We're left with this number. We're left with, what number is this? This number is 8. Thank you, applesauce. So when we're looking, right, 2 times what is equal to 8 or less? If we can do this, right, if we can do this, we would move our number over here. Thank you. So it would be 4. Add the 4, take away the 8, take away the 5, take away the 3. So our final answer is 74. Can you degrade me into locking in for college? I'm failing math and I'm probably not going to get my grant. I don't know what that means, Caboose. Thank you, Jess. Yes, please. If you guys can tap the screen, that'd be great. What a long way to get an answer. No, it's a slower way to get the answer, but you could use a calculator. Go right ahead. Can you do another one? I just joined the line. Okay, part 7. All right, we'll do another one. Because everybody seems to be very excited for division. Right, used my brain. That's fantastic, too. Well done. Good job. Well done. Good job. You can go right ahead and open up your own live. Can you explain the... I don't know that. That is above my pay grade. All right. Let's find another one. Could you use your brain or do it super quickly? Yes, but then I'm not teaching. It would be really boring if you just saw me do this. Okay, let's try this one. I think they're replying to Chewy Guy. The trolls are coming out. And confusing. It is confusing. Division is a little confusing if you're not strong in multiplication, and if you're not strong in multiplication, division can be confusing. But don't forget, it's always about process, right? And progress. Hello. I give you my full attention. Okay, we're going to do it again. You play it so well. Oh, thank you. Thank you so much. I appreciate that. Okay, we have 4 divided by 228. This is not this complicated multi-step way. Division is a special... It is a special treat. It is a special treat. Oh, I don't have my... Anyways, so. I'm excited to see the division. Okay, so here we go. Again, what we're going to do is we're going to find our numbers, right? We have our dividend, 3. 1, 2, 3. There's 3 digits on the dividend. What did we just do to the abacus? Nothing. Oh, nothing. I didn't clear it. Minus 1 divisor. Why are we doing this? Because we need to figure out where our starting point is, right? So we have 2. 1, 2. 2 is right here. So I'm going to put my dividend on the abacus. 228. We're using this as a placeholder. We're not using it as a place value. This is just 222. So I'm going to put my finger here. Now remember, 4 times what is equal to 2? 2 is our dividend. 4 is our divisor. Can we do it? No, we can't do it. We have to make it into a double digit. Right. It's 22. Thank you. 22. Thank you, applesauce. So 4 times 5 is equal to 20. So I put 5 on my abacus. Oh, can't see that. 5 on my abacus. Take away 2. Take away 0. What else? We can do it. We bring. Okay, so now we're ready, right? Take a look at here. We do the next one. 4 times what is equal to... What number are we doing? I'm lost on the abacus. What number is this? Two. Well, start off with 2. Start off with 2. Can we do it? No. Why do we do this? Because we want to, this is where we get critical thinking, right? We want to understand why we're doing it. There's no multiplication fact for this, right? So what we're doing is what? You got to bring down the 8. So 4 times what is equal to 28 or less? 4 times 7 equals 28. Yep. 4 times 7 is equal to 20. Take away 20. Take away 8. She added the 5 and then what happened? Whoa. The 5? Oh, here. The 5. Okay, so I added the 5. So I added the 5, right? I added the 5 and I take away 20. Take away 2, take away 0. Take away 2, take away 0. Take away 2, take away 0. Does that make sense, Mio? Then we redo it again. Because we're using this to take away. We're using this to take away. We're using this to subtract. That's what this is, right? We have 20, subtract, right? And then we're left with 2. Maybe I should do it. Maybe I should do it here, right? So just like in mainstream, you do 5 is 20, right? Then 2, and then you bring down the 8. But you don't know why you bring down the 8. You just know you bring down the 8. And then you have 7. So that'll be 28. And then equals to 0. So this part here, well, that's what we did on the abacus, right? So we have 2, 2, 8. So we take away the 20, and then we take away the 28. Crazy train. Yeah. So what we're doing here is exactly what we do on the abacus. Does that make sense, Mio? You guys are funny. Okay, good, Robert. Yeah. Sorry, can't stand nuts. I know. But I couldn't break my concentration to cook some trolls. I wanted to cook some trolls, but not when I'm in the middle of a lesson. Yeah. Yeah, not in the middle of a lesson. So, you're still here! Thank you so much, Houdini Light, for commenting. I appreciate you wasting your time in my room. Thank you. Using Abacus looks cool. Oh, hello, Dahlia. Delilah or Dahlia? Delilah. Dahlia. Yeah, don't worry, we got you. It doesn't matter. The answer shows on the Abacus. Yeah, exactly. The answer shows on the Abacus, which is really crazy. I'm an observer. You're a very loud observer. The Abacus is a counting tool. Yeah, crazy, right? But if you're offended by the propaganda, why are you observing? Why doesn't the answer show on the Abacus? Oh, because I took it out. It's supposed to be 57. Sorry, 57. That's what it's supposed to be. Sorry, Catherine. You're still observing and you're still commenting. Welcome, Houdini. Welcome. Oh, not a problem. Not a problem, Catherine. I'm happy to help. So here, let's do a little review. Here is 7, and then this is 5. The top beat is always a value of 5, and then the bottom beat is a value of 1. So we have 1, 2, 3, 4, and then we have 5. The top beat is a value of 5. We have 6, 7, 5 plus 2 is 7, 8, 5 plus 3 is 8, and then 9. 5 plus 4 is 9, and then we have 10. 10 is a 1 and a 2. I'm offended that you're being offended. I'm offended that Wheels is offended that Houdini's offended. Hello, Michael! Yes, I'm watching you at work. Yes, man. All right. Michael, we were doing some division. Oh, you know what? I was going to find this one other division question that I found. I found this one other division. You know what? I'm going to do this one instead. Let me see if I can do this one. Nope, that's not right. Nope. It is. Nope. There it is. All right. Let's see how this works. I don't know if this works well. Let's see how big number this gets. Okay, let's see. I'm imagining 2 laptops while following the lesson. It's a challenge. Ha ha ha. Oh, really? You're imaging? 9 divided by 8, 6, 2, 7, 4. We can do it. It'll be easy. 1, 2, 3. I'll put the comma here. No! It'll be fine. It'll be fine. Wheels, I'm drawing and painting a font. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? 5 take away 1 is equal to 4. Thank you, Wheels. 1, 2, 3, 4. I put 8, 6, 2, 7, 4. Now what are we going to do? Can we see what's going on? There we go. We do it again. 9 times what is equal to 8? Can you do it? No. Because remember, the 9 is the divisor. The 8 is our dividend. Thank you, Jess, for the roses. Michael, you still here? This is for Michael. We need to make it a double digit. How do you do it? How do you make this a double digit? 86. You're right, 86. So now, 9 times what is equal to 9 times what? Bring down the 6. Thank you. Bring down the 6. 9 times what is equal to 86 or less? 9 times 7? No. 9 times 9. Thank you. 9 times 9 is 9 times 9 is 9 times 9 is what? 9 times 9 is 81. So I put the 9 here. Do you see that? My quotient is right here. I put the 9 right here. I take away 80 and I take away the 1. Got it? Now what? We're going to stay here. Because if I use this, it's going to get me wrong. Because what did I do? I took away 81. So what is next? 9 times what is equal to 5? Always start with one number. Can we do it? No. We cannot do it. What do? We make it a double digit. How do we make it a double digit? So good so far? Good. Right? Thank you. It is 5. And then how do we make it a double digit? Thank you, Jess. It is 2. Yes, it is 2. So what times 2? So what times 9 is equal to 52 or less? You guys are amazing. Bring down the 2. Yes. Thank you. You bring down the 2 because we want to make it a double digit. 4. 5 times 4? No, 5 times 5. 9 times 5 is equal to... What is 9 times 5? 9 times 5 is equal to... 45. Thank you. 45. Add my 5 to my quotient. Add my 5 to my quotient. I take away 4. Can't do it. What do? Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. We're over here. Take away the 5. Minus the 5 is what? Minus the 10 plus the 5. Minus the 10 plus the 5. Now what? 9 times what is equal to 7? Can we do it? No. We cannot do it. What do? We got to make it double digit. We got to do 7 and then bring down the 7. Thank you. 7, 7. So what times 9 is equal to 7, 7 or less? Hard to keep up with multiple. It is hard to keep up. Don't worry about it. You know what I mean? It'll come later. 9 times 8 is equal to 70 to what? 72? Is that right? 72? Thank you. 72. Add the 8 to my quotient. There's my quotient. Because it moves, right? Take away 7. Take away 2. Take away 7. Take away 2. I'm left with what? 9 times what is equal to 5? Can we do it? No. We can't do it. What do? We got to make it a double digit. Thank you, Michael. Oh, I got it. Good, NC. Make it a double digit. Bring down the 4. Thank you. 9 times what is equal to 6? Is it 6? No, I don't think she did. Nope. 6. Add the 6. Take away 5. Take away 4. So what's my answer? My final answer is... Mio, hold on. What's my final answer? Nine, 5, 8, 6. Just for Michael and NC. Yeah. Okay, Mio. So, where did you get lost? 1, 2, 3, 4. We do, what is it? 8, 6, 2, 7, 4. All right. So, I just got lost and started crying. I can't really multiply. Oh, okay. You know what? Then don't worry about it. Cuz when we go into it, we'll get into it. Or remember. No. Right now, don't worry about it. This is a little bit more complicated because we're doing the 9 times table. But what if we did the 2 times table? You know what I mean? But this is later. This is just later. You just started. Don't worry about the 9 times table. You just started. Don't worry about it. You know what I mean? You will get there. I was focused on the process and wasn't reading the Sorobon. Thank you, Jess. Thank you, Jess. Oh, Michael. 9 times was the answer. Yeah. 9 times this would be the answer to that. Yep. Right? So our divisor is always going to be the 9. So you follow the 9 all the way down. Yeah. I've watched 5 Lies where she's covered the basics of multiplying. I'm so excited for division. Yeah. Yeah. So I try to keep all the divisions the same. And, I talk about it, but yeah, I'm still trying to figure out a better way to explain it on paper. Because it's different than mainstream math. But I think I figured out my process. I just have to figure out how to explain it on paper. Oh gosh, thank you so much. Thank you so much, Jess. Hello. Hello, Jen. That was a great process. You'll get it, Mio. Just be patient. All right. You know what? This is normal division to me. It is normal division, kinda. It's a little different. We're gonna do this without paper though? No. Okay, Jess, see you later. See you later, Jess.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
We're gonna do this without paper though, right? What do you mean by that? Oh, thank you. Thank you, Wheels, for the tiny dinosaur tiny diny. I don't know what it is. I think maybe you watched it in your head. I don't know. I'm not sure what that means. Oh, it's a hot dog. Ah, yeah, it was a hot dog. Thank you. All right, we can do another one. Because Jen came in. Now we got to do another one. Hold on, Jen. Okay, you know what? Instead of 9 times table, we'll do 3. We'll do 3. They were scared because I got the bigger numbers. I don't know why. Don't be scared. Thank you for the donut. Thank you, Michael, for leveling up. All right. Here we go. You guys are awesome. Yeah, thank you guys. Thank you so much for the gifts. 177633. This will be easy. It's funny how easy it is now than it was before. All right, here we go. 1, 2, 3, 4, 5, 6. Whew, that's a lot. 1, 2, 3, 4. No, 5. No, 6 dividends minus 1 divisor equals to 5. So 1, 2, 3, 4, 5. Our quotient is going to be here. We do 1, 7, 7, 6, 3, 3. Whoa. Oh, hold on, Mio. So it's first 3 times what is equal to 1. Because we got to make this a double digit, because there's no dividend for this, right? Because there's no dividend, because there's no multiplication factor for this, we got to bring down the 7. Yes, now we bring down the 7. Does that make sense, Jen? Oh, no, this fits. This will fit. This fits. This fits. Jen, you okay? Size matters. Size does matter. So we have 17. So 3 times what is equal to 17 or less? 3 times what? 3 times what? 3 times 4? No. 3 times 5. 3 times 5 is equal to 15. Because we want to get to as close as possible. So we do 3 times 5. 5 is here. Add the 5. Take away 1, take away 5. Do you see that? We took away from our dividend. Notice that now we just move forward. As we move, our quotient gets bigger. Our quotient keeps adding. So now we're here for the quotient. So we have our next number. 2. 3 times what is equal to 2? Can't do that. Hello, Crispy. Hello. Just in time. Just in time for some division. Thank you for the hand heart. Thank you so much. So we can't make this. How do we make it? Bring down the 7. Yes, bring down the 7. Thank you. Uh-oh. I did that wrong. Oh, I did that wrong. Holding. Hold. 3. Nope. Oh, I did that wrong. I gotta start over. Sorry. Wrong number. Start over. 3, 2, 0, 3, 6, 7. That's what it is. That's what it is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 divided, take away is 1. Do it. Okay, sorry. 1, 2, 3, 4. Sorry. That was a wrong number. There we go. Okay. Sorry, back to back. Hello, Robert. Hello, Robert. I'm still here. We're doing some division. Okay. Sorry. Yeah, see? I make mistakes. Don't worry about mistakes. Okay, so we have 2, 0, 3, 6, 7. There we go. Okay, we're starting over again. I need more practice. Yeah. Okay. 3 times what is equal to 2? Cannot do it. We got to make this a double digit. Bring down the 0, right? 3 times what is equal to, thank you, bring down the 0. Thank you, NC. Thank you, Mio. So 3 times what is equal, closest to 20? 6? Yes. 6 is equal to 18, right? So you add the 6 to the abacus. I added the 6 to the abacus. I want to take away 18. Take away 1. Take away 8. Take away 1. Take away 8. Take away 8 is what? Can you do it? You cannot take away the 8. What do you do? Take away the 8 is what? Minus the 8 is what? Minus the 8 is equal to minus the 10 plus the 2. See, this is, you still need to know your multiplication. You still need to know your math fact. Yes, take away the 10 plus the 2. Thank you, NC. So now we have it again. 3 times what is equal to 2? This one. There's no multiplication fact. We need to bring down our next number. What number do we bring down? We have to make it a double digit. The double digit to make it is 3. Jen, you following? So 3 times what is equal to 23 or less? Can't see that. 3 times what is equal to 23 or less? 3 times 7. Thank you. 3 times 7 is equal to 21. So put 7 as my quotient. Notice my quotient is 6. There's a 7. So now I have to take away my dividends. My dividends are here. Take away 20. Take away 1. I wasn't forced to memorize during the early grades. Yes, you do have to start memorizing your formula. You do have to start memorizing your multiplication facts now. If you want to do abacus, a division abacus, and multiplication abacus, you need to know this. Yeah, but it's a good exercise. It's a good exercise to get you started. And now there's a reason. Because, before, there was no reason to memorize. You know what I mean? There was no reason to memorize. But now, if we're doing the abacus, there's a reason. And it's simple. You know what I mean? It's super simple. So we have our next number. 3 times what is equal to 2? You can't do it, can you? So we got to bring down our... What number do we have to bring down? We have to bring down 6. Thank you. So what times 3 is equal to 6 or less? 26 or less. 6? 8. 8 times 3 times 8 is what? 24? Add the 8 to my dividend, or to my quotient, right? And then we take away 20. And then we take away the 4. Minus the 4. Minus the 4 is what? Minus 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. What are we doing? Thank you. Minus the 5 plus the 1. Now what? Do it again. 3 times what is equal to 2? Can you do it? No. We got to make it a double digit. What's the double digit? 7. Thank you, Mio. 3 times what is equal to 27 or less? Thank you. It is 9. Add the 9 here. Take away 20. Take away 7. Catherine, why are you screaming at your screen? Is it okay? Thank you. It is 6, 7, 8, 9. 6, 7, 8, 9. I hope it was easy. Off topic. What division for abacus could be... I'm sorry. What division for abacus can be used for? Whenever you do division, like, I don't know. Like if you have like pizzas and you want to divide it up or stuff. So we do long division. When do you ever use long division? We use calculators. But what we want to do is we want to keep our brain active. You just want to keep your brain active. Can we try the 7177 number equation again? Real quick. Yeah, just quick fingers, so wrong numbers. Yeah. Hey, sunset! Haha, that's funny. All my lives on my FYP. Okay, hold on. Let me see. Let me see if I can... I have to find it now. So... Okay. Ready? For me, this is a great way. I love letter games, and this is the only going to add that. Oh, yeah. Is there a reason why you didn't want to do it? Because it's super long. And I thought I did it wrong. All right. Let's try it again. Sorry. Okay, so 3, 1, 7, 7, 6, 3, 3. All right, all right, all right, all right. I was thinking that I did it wrong, but I guess not. Okay. 1, 2, 3, 4, 5, 6. 6 take away 1 is equal to, okay, we're here. 1, 2, 3, 4, 5. This is where the quotient is. 1, 7, 7, 6, 3, 3. All right, all right, all right. We're ready. Okay. So we do 3 times what is equal to 1. Can't do it because remember we talked about 7, right? So you said that was 3 times 5 is equal to 15. All right. So add the 5 here. Take away 1. Take away 5. Right? Now we're here. Three times what is equal to 2? Can't do it. We have to do what? I'm covering up the number because there's no room. But we want to make this a double digit. What do? We make this a 2 and a 7. 7. Right? Bring down the 7. 3 times what is equal to 27 or less? Thank you. Bring down the 7. Yes. So 3 times what is equal to 27? 9. 3 times 9 is equal to 27. Add the 9 here. Right? There's my quotient. 5, 9 is my quotient. Take away 20. Take away 7. And then we're here. 3 times what is equal to 6? Can we do it? Yes, we can do it. This is a rule. If we can do it, we have to skip this question. We have to skip this column and go here. Because you can do it, you have to skip. That's the one thing. That's the one thing you have to know. That's just it. Right? So yes, 3 times 2 is equal to 6. Add the 2 here. Take away the 6. And then we do it again. You have to skip this column. My 8-year-old independently requested for an abacus to help with math. That's fantastic. Never heard of it. Oh, that's fantastic. That's fantastic, Alexandria. The last step. Because you can add, because there's a multiplication fact. Because you can multiply this, you have to skip this column. And it puts you here. You have to go back one column. Are you making up rules? No. That's just one of the rules. We just never got to it. Because I was very careful with curating my questions. Yeah, that's one of the rules in division. If it's a single digit, just like single digit, you need to make it a double digit, right? If it's a single digit, you got to make it a double digit. This is one of the rules. You got to make this a 0. Because you can divide it. So you add the 2, take away the 6. That's why you wanted to skip it. Nah. It gets a little confusing, but that's the rules. So here, do it again. What? Oh, shit. Because we can divide it, you make this into a double digit. Then it becomes a 0 and a 6. A 0 and a 3. That's why we're here. That's brilliant. That's brilliant. Because this is a single digit. No, that doesn't work. No, it does work. Because it's a single digit and you can divide it out. So 3 is equal to what? Can you do it? You can do it. What happens? This becomes a 0, 3. This 0 pushes your quotient back here. Thank you. 1. Add the 1, take away the 3. Do it again. Add the 1, take away the 3. That's brilliant. That's brilliant. I'm so lost. Why are you lost? I get it. That makes sense. It makes sense, right? Holy, I need a workbook of all these rules. That's not it. That's not a rule. It's the same rule. It's the same rule. What's the rule? Hold on. I gotta find my paper. Where's my paper? It's the same rule. Here, this one. This one. It's the same rule. If it's a 1, it's a 0, 1. If it's a 2, it's a 0, 2. If it's a 3, it's a 0, 3. If it's a 4, it's a 0, 4. It's the same rule. No, it's 5, 9, 2, 1, 1. It's the same rule. Have a good night. Have a good night, Mio. It's the same rule. This is my single digit. The single digit needs to be a double digit. So when we're looking, Jesus, that makes it so much easier. 6. Usually usually our quotient is sitting right here. Our quotient sits right here next to here. But what happens is this is a single digit. If it's a single digit, we have to remember that there's a 0. The 0 is what pushes our quotient back 1. Because this is a single digit, our 0 pushes our quotient back 1. That's why we skip this one right here. Holy shit, man. That's brilliant. That's brilliant. I can't believe it. Okay. As many times as I've been teaching this, I've been trying to rack my brain so much. Why do we skip? And this is why. If this is a single digit and you can divide it out, the 0 pushes it out. Just like we do our double digits when we do multiplication, right? When we do multiplication, 33 times that by 2, right? What do? We do 3 times 6 is equal to, 3 times 2 is equal to 6. 6 becomes what? 6 becomes a 0, 6. So if 6 becomes a 0, 6, because it's a single digit, it's the same thing with here. Because you can divide it and it's a single digit, you got to make this a double digit. So that's why you get pushed out to here and you put the number here. It's a 0 and a 6. That's the Desali rule. Does that make sense, Michael? Jen? Because you know how to multiply, you will know how to divide. There's a rule. You always want to make it a double digit. To make it a double digit, if this is a 6 and it's a double digit, you got to use a 0 here to push it out to here. Damn it. So then I do 2 here, take away 6. Okay. I'm done. I'm done. I got to go work on my books now. Holy shit. Right? Does that make sense? Crystal clear. Now I know about the 0 rule. I just have to, I must have missed it. Yeah. So, yeah, because it's not, obviously it's not all the time. It's only when it's a single digit. It's only when it's a single digit you have to make it a double digit. Yeah. Is it a rule? It's not. It's just uniforming. It's just making the uniform, right? If it's a double digit, make it a double digit. So if it's a single digit, make it a double digit. Yeah. There we go. That makes a lot of sense because when I divide, I always sit really close to the dividend. It's always next to the dividend. Oh, Jesus. I'm okay. I'm flabbergasted because we were taught to memorize rules, but we were never taught to know why. And I am discovering why am I learning this rule. And they had this whole like story behind it. You open your own mind. Yeah. I knew about the zero rule of multiplication, but now I need to know how it works. So I'm happy to see simple multiplication. Hello. No, no, no. We were actually doing We were actually doing division, treasure. We actually did some division. The zero rule is why we go back. Yes. So okay, what's the? We had the number 5. Was it 5? 5, 9, 2. Okay. So 1, 2, 3, 4, 5. So we have 1, 7, 7, 6, 3, 3. Okay. So notice we did 5, we took away that. We did 9, we take away that. Okay. So notice here. Notice there's a 0 and a 0. Whenever we go through the quotient, it's always going to be next to the dividend. Do you see that, Michael? It will always be next to the dividend. But the problem is when it's 3 times what is equal to 6. Because you can do it and it's a single digit, you got to make it a 0. So that means this pushes it to here. This is a 0, this is a 6. That's why. Because this is a 6 and it's a single digit, the 0 pushes it out to here. So my quotient actually sits over here. That's why. Just like in multiplication. You add the 2 here. You take away the 6. We do it again. 3 times what is equal to 3? Nowhere goes to, well, I'm sorry. Nowhere does the 2 go. The 2, if I put it here, if the 2 goes here, then your answer is wrong. You need to make this a double digit. You need to make the 6 a double digit. So that's why it pushes the number to here. So where does it go? It goes next to the quotient. Because you imagine that this is a 0. This is my dividend. There's a 0 here. And then this is my 6. Because it's a single digit, that's where my dividend, this is the imaginary dividend. Yeah. So we take away then we do it again. If I can do this, it's a single digit. Now I got to push this. My dividend is here. So it pushes my quotient here. I'm still next to my quotient. I'm still my quotient is still next to the dividend because I have a 0 here. I have to remember there's a 0 here. So now 3 times 1 is equal to 3. Add the 1, take away the 3, and then do it again. Add the 1, take away the 3, because that 0 needs to be recognized. The 0 is what helps you push it. This is why I didn't make my book yet, because I felt like there was gaps in it. I have no clue, but I'm comfortable with the double-digit math. We're not doing double-digit math. We're doing, so it's 3, 1, 7, 7, 6, 3, 3. So we put the dividend on our abacus. We do 1, 7, 7, 6, 3, 3. Right, Michael? Does that make sense? Because we have to recognize that there's a 0. So then when we do this, it's 3 times what is equal to 1. I just purchased the abacus and the mazes. Oh, yay! Thank you, Desali. Yeah. It's so crazy. Yeah, I've been wrestling with this. I couldn't figure out why we did that. All right, Treasure, what are we doing? We got to make this a double digit. I know, I'm becoming more comfortable with multiplication. Oh, I'm starting to understand. Oh, good. Oh, good. So we have to make this a double digit. So 3 times 5 is equal to 15. Add the 5. So we take away 1. We take away 5. And then we're left here. Right? 3 times what is equal to 2? Can't do it. You got to do this double digit. You got to bring that down. So this is a 9. So 3 times 9 is equal to 27. This is new. This is new. 27. It is new. I just kind of whipped this one up. So then the 6. Can we do it? Yes. Do you see that it's a double digit? If it's a double digit, we got to make this a double digit. It's a single digit, we got to make it double digit. It becomes a 0 and a 6. Because it's a 0 and a 6, we got to do 0, 6. So that means if this is a 0 and this is my 6, my dividend's here, my quotient needs to be here. So it is actually 2 times 3 is equal to 6. 2 times 3 is equal to 6. And then we do 3 times what is equal to 3. 3 again is a single digit. Because 3 is a single digit, you got to make it a double digit. That means this is part of my dividend. So that's why my quotient is here. I add my 1. So 3 times 1 is equal to 3. And then we do it again. I'm tired. I grew tired of learning how to count numbers on the abacus. Huh. You don't understand. I know how to count really well, and I've been doing it for 20 years. And 3 times a day. So we have 1. There we go. That's interesting. Yeah, we have to make it as double digit. All right. I am spent. I've been on for about 3.5 hours. Thank you everybody for joining. It is 500, it is 59,211. I know, I'm not just, no, I understand because there's a lot of people that have asked, but the thing is if you want something more and you don't want to wait, I do have a membership. Yeah, 3 hours. Come on, another hour to applesauce. I'm going to have my hamburger. I'm so excited. I'm excited to see something more. Thank you for showing us this. Yeah, not a problem. Thank you for showing your knowledge and kindness. Yeah, not a problem. I appreciate that. Placement is my struggle. Hard to calculate and watch this. It is hard to calculate and watch. Go have dinner. It's a midnight snack now. I was actually going to leave. But I'm at 250 people in my room. This is crazy. It is so crazy. 250 people in my room, and we're talking about multiplication and division. You know what? You know what? This just means that I got to break out my book more. But guess what? I have to go through these motions before I can make my book better. My book will be better because I have all these revelations. You can use the cubes or something to count. Haha. Will you post this view later? What time tomorrow? I think I'll be on at 6:30 in the morning. Do you know how to do graphs? No, El Jefe. If you want graphs, if you want to do algebra, I know somebody who does algebra. Give me a DM and I can send you to her. Thanks for indulging. Oh yeah, not a problem, Wheels. Thanks for bringing me up to 69,000 likes. For us to review later, to replay. Woo, geometry? Yeah. Let me know, DM me El Jefe, and I can send you to somebody who does geometry. She does geometry. I only do abacus. I only do adding, subtracting, multiplying, and dividing. That's the only things I do. Yeah, not a problem. Yeah, if you're looking for somebody to help you with that, yep. But yeah, that's the thing. That's the thing. Like, if you want something more in depth, obviously, it's kind of sporadic when I do it on live. But if you want to go something in depth, I have a membership. Michael, I would have to think of a better. I wouldn't do a big one like this. I would do something smaller. I could do something smaller. I'll do one. Yeah, I could do that. I have to be up for FedEx delivery server. If I'm alert, I'll wake you up. I'll see you at the AM. Okay, cool. New server. Woo, new server. What kind of server? Is it a algebra, calculus, geometry using the abacus? No. Adding, subtracting, multiplying, and dividing. No algebra, no calculus, no geometry using the abacus. No. No. This is only meant for fundamental. What kind of server? Wheels? Now I'm excited. Ooh, it's a NAS. Ooh, with a Xeon. Ooh, that sounds fancy. I don't know what the Ancestor is. I know what a NAS and I know what a Xeon is. I don't know what an Ancestor is. That's a new one. Do you hear what I hear? No. Focus on OEM. Oh, interesting. Ancestor is the storage. Oh, that's interesting. The words are coming in. That's funny. Yeah. I was going to do another one. Oh, I was going to do another one. I found it too. I'm thinking. So, yeah, I'm excited for the books. I'm excited for the books. I just got to figure out like how I want to set it up. I don't know. I'm still going to have the activities for the books. I think I was just going to do the mazes for multiplication. Yeah, I was going to do multiplication. Multiplication for the books for right now, and that would be the quickest to get out. And then the division. The division will be good too. That's funny. I can do all of this and it wouldn't be a problem. This wouldn't be a problem. The problem lies when there's more digits. Yeah, okay. So mazes it will be. Which funnel hacking live did you go to? I didn't go to a funnel hacking live. That was too expensive. Maybe a group who understands how to read the abacus would be a bit more. I love that we're basically a sounding board of your audience. Yeah. Well, it yes and no. The class needs to be advanced enough to go to this level. Most of the time the class is not at this level. I did buy the book and I'm supportive. Oh yeah, thank you, Treasure. I appreciate that. Yeah. Yeah, that's the thing, Wheels. It's like it's only enough if the class is up to speed. If the class is not up to speed, if I get too many beginners, then I'll go back and I'll go back to the beginning parts. That's why. So yeah, Robert, I didn't go to a funnel hacking live. I went to it was an online one that was free. It was one with Russell Brunson. It was okay. I did buy into the ClickFunnels for a little bit, but then I'm now on high level. So see you later, Michael. I don't know if I said that. How do you teach long division with an abacus? I just did, and I'm spent. And I guess you're gonna have to wait for the book, or try my other lives, or I did do a division in one of my posts. Yeah. I'm quite excited for this. I'm very excited for this. Because if you know how to add, you know how to subtract. If you know how to multiply, you know how to divide. Yeah. It's just interesting about all the patterns. All the patterns is just fascinating. Yeah. All right. Sorry, Rosa. I'm spent. I've been dividing for like what, 2.5 hours now. You guys, one right after the other. Yeah, that's interesting. No, it's good. I joined. Oh, I see. Yeah, you can do long division on the abacus, but I'm a little bit spent right now. Yeah, I don't know how people can go on for like 5-6 hours, but they're not doing what I'm not. They're just talking. I'm like, I don't know. Yeah. Okay. All right. Have a good. Yeah. Thank you. Go. Thank you. It's like 6 or 7 hours. Yeah. I'll probably see you like that. Sorry, I missed the division. Yeah. Have a good night. Thank you. Looking forward for the next one. We're gonna do the same thing again. We're talking about it. We're talking at they're talking at and you're talking with. Energy is different. Oh yeah, that's for sure. Yeah, you're right. Math takes a lot of mental energy. Have a good night. Thank you, everybody. Thank you. You're right. You're absolutely right. Thank you, Wheels. Thank you. Thank you, Robert. Yes. Have a good night.
We are so glad you came. Bye-bye. 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 Bye-bye now. Bye. Bye-bye. Remember, please discard all candy wrappers and popcorn containers in the nearest trash receptacle. Thank you. Okay, bye-bye now. Bye-bye. Bye. Okay. Are they all gone? Is everybody gone? Huh? Good. Oh my gosh, my cheeks are killing me. I can't keep smiling like this anymore. I am exhausted. I think I need a break. A little break? Okay.
All right. Have a good night, everybody. Thank you so much for joining. Bye.
Oh, and in case I don't see you, good afternoon, good evening, and good night.